Well, hello, Internet, and welcome to the beginning of machine learning. I am going to start off with Octave because it is often a language that is used in a lot of tutorials out there, so I think you need to know it. And another really awesome thing about Octave is if you learn Octave, guess what? You automatically learn a lot of Matlab, which is also extremely beneficial. So I'm just going to just jump in here and start writing some code, and feel free to ask me any questions that you have because that's the reason why I am live streaming. And let's jump over to this guy right here. And this is basically what I'll be covering. I'll be covering basic user input and output variables, casting, all the math operators, conditionals, how to work with vectors and matrices, looping, matrix functions. We're going to be doing a lot of math-based stuff because machine learning is basically math. String structures, file I/O, functions, anonymous functions, recursive functions, plotting, and depending upon the number of viewers that I have at the end of it, I am going to actually go into Andrew Ng's first assignment, which seems to throw a lot of people off, and I will show how to calculate a cost function in 3 ways. I'm going to show you, if you don't know what a cost function is, don't worry about it, I'll explain it later. But basically, I'm going to explain it. I'm going to show you how to create a cost function on paper, so you'll actually be able to write it out. I'm then going to show you how to solve it using for loops, and then I'm going to show you how to solve it using matrices. So 3 different ways, and that's pretty much what I'm planning on doing with my machine learning course. Is I have, over the last probably 2.5 years, I've received countless numbers of questions about other people's courses, and I've had to go in and explain, well, yes, this is the calculus behind that, and this is the algebra behind that, and this is the linear algebra behind that, because very often in those videos, even though these people are way smarter than me, sometimes it's actually better to talk to somebody who is not as smart, because I can say, okay, don't ignore this calculus. This is actually how it works, okay? And because I have found that a lot of people in watching those courses have found that to be a problem. Very often really smart people go, this is calculus, but don't worry about it. You don't really need to understand it. And then, 10 videos down the line, you basically have to understand it and you're completely lost. So what I'm going to do is make it 100% clear. That is my goal. And so there you go. And I often think that solving these math problems on paper actually makes them more understandable. And so that's what I'm going to do. All right, so basically a comment in Octave just begins with a percent sign, just as you can see right there. And user input and output. So let's say we do something like CLC is what you type if you want to clear your command window. And I went in to Octave and made everything. I completely redid all the coloring. So if you get this, you're not going to see it. And if you just type in Octave GUI, that's what I'm using. That is the interface. Octave is, if you want to understand machine learning, see, my goal here, the question was, does Octave actually have any use cases in 2022? Yes, Octave is used a lot. It is considered to be a Matlab replacement. Okay, so just purely there, it is a free version of Matlab, basically. So is that useful? Yes, it's very useful. On top of that, most of the machine learning courses out there, a lot of machine learning courses out there start with Octave. And if you don't know it, you're just going to be confused. Now, has everything moved into Python? Yes. But Octave allows you to sort of ease into the process and really, truly understand the math of machine learning. And then once you understand that, you can move into the Python solutions. So I think, yes, I believe Octave is extremely important and useful to know. All right, in multiple different reasons. Okay, so let's say we want to accept user input. All we're going to do is type in name is where the input is going to go. And we're just going to type after input, what's your name? And all this code will be available on GitHub after I finish this. Let me see something. I thought R and SQL. I was hoping you had some tips to keep it all together when trying to learn them simultaneously. I don't know. Basically, I don't think it would be that hard if you know Python to transition into R. I know it wasn't a big deal for me. And I don't know. You just have to do it. Put in a certain amount of time every day. Learning two languages, you're actually learning two languages at the same time. I really wouldn't advise that. I'd much rather nail Python and then move on to R. But if that's the situation you're involved in, then that's what you have to deal with, I guess. Let me move this down here so you can see your chat messages. I don't know. What I basically do when I'm learning something is I just designate a certain time of day and I spend an hour learning that one thing. I think it would be much more beneficial to just learn one language, but so is life. Okay, so we're going to type in what's your name. This is just basic input. We'll get much more complicated. By the end, we're going to be doing basically machine learning problems, so it's going to get considerably more complicated. If you do not want any output to show up in your command window over here, you're just going to put a semicolon here at the end of it. So now name is going to have whatever the user typed in. Oh, and if you're wondering what this S is here, this is saying what Octave will do is it'll try to figure out what data type you are using. And if you want it to be treated as a string, well, you just put that there. And then you will be able to work with it. Okay, so what we want to do, we're going to jump ahead to if statements here a little bit because I think you guys can definitely handle it. What we're saying here is if the input that they supplied, which is in the variable name, if it is not empty, okay, so that's not, this is going to say, is it empty, and either provide a true or false based off of whether it's empty or not. We're going to say if not is empty. Yes, that's really bad English. We are going to check that. And then you're going to have to use end statements inside of Octave. And again, this is exactly the way Matlab also works. And there's multiple different ways to output information. I'm going to show you all of them. I'm going to say hello. And then if you want to have your string show up inside of there, which is going to be the value stored inside a name, you just put a % and an S. If you want to have a new line, you just put in a new line like that. And then if you want to follow it up with whatever they placed inside of there, you're just going to put the name. And then at the end, of course, you need to, well, it's not of course, this is something a little different. Actually, the white space doesn't matter, but we're just going to do it this way anyway. And if we run it, you'll see what is your name. If I say Derek, it's going to say hello, Derek. Okay, so basic input. Now you're going to be able to enter basically any type of data, and it's automatically going to figure out what type it is. We're going to be working a lot with vectors and matrices and such, and so we are going to just allow them to enter a vector into our variables here for us. So we'll say enter a vector, and then we will follow that up with just a statement here. Well, let's put a space inside of there like that, and like that, and like that. And then they enter whatever their vector is, and you can also use display for simple output. So I'm going to say v input like that, and we can run this. We can go and comment this out. I don't believe, actually, nope, the GUI is not intelligent enough. Let's just comment it out like this temporarily. I don't want to get rid of it off the screen 100%, so I'm just going to throw some comments inside here. The GUI is a little bit but I have found it to work well enough. So we can just go in here and we can say type in a vector, and you could just simply do like this, 2, 3, and 4, for example, and it's going to automatically output it as a vector. All right, so there you go, the basics of input and output, and we'll do some more as the tutorial continues. Now, in regards to variables, and if at any point in time I say something doesn't make sense, just ask me. You can also do multi-line comments just by putting a % sign and this little symbol here, the little curly bracket. Missed first 15 minutes. What do I need these to... Oh, what do you need to install? Here, give me 1 second. I will show you exactly where it is. So let's bring this up. I probably should have did that, but I figured I'll just say go to, type in GUI. There it is. GNU, Octave. That's not it. I'm going to show you. I'm going to actually show you the website. It's very easy to install. It works on every OS. And it's just GNU, Octave. And let's bring this up here like that. And here it is. There we are. Here is the website. So you're just going to, if you just type in exactly what I said, Octave GUI, G-U-I, it's going to bring you here, and you just click on download at the top of the screen if you can, and then you're going to pick your operating system and just download it. And it's pretty simple. All right, so no point in even knowing what this is. Just type in Octave GUI, and you will find exactly what you are looking for. All right, so hopefully that helps. Now, basically, variables in Octave are going to start with a letter, and then you're going to have numbers, and you can have underscores. And data types are classes, which also have associated methods for working with the different types of data that you're messing around with. And you can use all of these different data types, but it is not all that common to define them like so. So let's just come in here and give you just a rundown. So let's say you wanted a character. You could just type in like this, and there you go. And once again, well, let's take it off. Let's get rid of that. So let's save it and let's run it. And you can see it shows up, okay? So the semicolon, what it does is it just keeps the output from showing up on the screen. See? That's all it does. All right, and if you want to clear your command window, CLC, and you can also do things like 1 + 2 like that, and the command window will allow you to interact with it, and you can basically write your code, all your code right here. I'm just doing it inside of the scripting area so it's more easy to actually understand what's going on. Okay, so there's a character, and let's say, well, we could go and analyze this variable that we have here. So if we can just type in class like that, and you're going to see that it comes back as character. What else could we do here? Let's throw a semicolon there at the end. The GUI is a little bit kind of weird. You can, of course, store different strings inside of it. So a string, and what else would we like to do? We can mess around with booleans. Booleans are going to map true to 1 and false to 0. So, and we can see that here if we just come over and say 5 greater than 2, and you're going to get an answer of 1 from that. And you can also go and assign using true, however. That's something that is totally doable. If you want to see the maximum and the minimum values, you can just type in int min like that, and then whatever data type you want to analyze, or you could throw a variable inside of there, and you're also going to be able to go in and do a max. So we can do min and max values like that and run it. Whoops, what does it say? True undefined near line. Well, I know that I did that before. Let's go like this. Oh, it's true like this. Boom, lowercase. Sorry about that. And run it, and you can see the minimum value right here and the maximum value right there. And let's say you wanted to do a different type of integer, you could do that as well. So just take this guy right here and throw that inside of here. Like, Octave is basically a free open source version of Matlab is what it is. And you can see there's more numbers, big numbers. What else would we like to do? Let's say you wanted to find out the largest double. You can type in, and you can also come in and go something like this. So we can run that and execute, and there we are. So here is the largest double that we have. And what else questions would we have? You could also continue using these different guys. Let's just go and erase this so it doesn't pop up anymore. And let's also go CLC like that. All right, so let's get rid of this guy also. Another thing that's neat is a lot of times you're going to be working with pretty complex formulas, and you might need to go across multiple different lines. So what you can do here is, let's just say, this very complicated formula that I'm doing here. You could just say 3, and then you could just go 1, 2, 3 like this, and then go down to the next line and plus and 4 like that. And let's get rid of the semicolon. And if we run that, you can see that we're able to spread our formulas over multiple different lines, which is also very, very useful. Let's keep that on the screen here for now. Anything else? I think that's basically it. So I'm just going to, well, let's get rid of it. Let's jump over into castling, and I'm going to move fairly quickly here like I normally do. And let's go into castling. So everything is going to automatically default to being a double, which is important to know. So if we go like this and create, maybe we want to do V2. Let's call it V2. And we want to see what V2 is. You can see clearly it should be labeled as an integer, but as you're going to see, everything defaults to double. So that's important to understand. So whenever we want to castle, let's say we wanted to, let's create, if we want to define the data type, what we can do is we can say v3 int 8, and let's, even better yet, let's go v2 is equal to 8, and then store v2 inside of here. So let's cast it this into a 8-bit integer. You can do that. And now if you come in and you look at v3 like this, you're going to see that yes, indeed, that is cast to what you wanted it to be. What else would we like? You could also go and take letters and cast those into different types. So you could do something like equal to double, and we could throw a letter inside of here, or a character, and that will work perfectly fine on its own. We could also convert to characters, so we could say something like v5 and character, and we could throw 64 inside of there to see what we would get from that. And if we go and run it, you're going to see that we were able to cast into all of these different types. And that's the basics of castling. Again, pretty simplistic stuff. So now let's get into math operators, and I also want to cover sprintf, which is useful. Basically, sprintf is just going to provide you with an additional way to format your strings and such. And the different ways of using them. So let's say you wanted to use an integer. In that situation, you are going to use a % and d. So that would be an integer for placing them inside of there. You could also, floats are going to be f. So we'll say floats, and exponential notation is going to be equal to e. I'm not going to type that out. Characters are going to be c. So characters, and what else do we have? We also have strings, of course. Okay, so strings. So those character codes are going to be used to format your output. And I'm going to use these in combination with different math operators so that you can see them. And there we are. So let's go 5 plus 4 is equal to, and let's say that we want to work with integers in this situation. We can throw a d inside of there, a new line like that, and then we can just simply do our calculation directly inside of there like that. And if we run it, you're going to see, there it is, 5 plus 4 is equal to 9. Okay, CLC, get rid of that again. Let's go and work with some other different operators. I'm just going to copy and paste because this is fairly simple to understand. Of course, we can use subtraction, and don't worry, it's going to get more complicated soon enough. We're also going to be able to use multiplication, of course. So I just change this to multiplication, and like that. You're going to be able to also define or work with the division, of course. So in this situation, we will do this. However, you're not going to get you're going to get a floating point value with this division. So you're going to be able to define how many decimal places you want. And how you do that, you go 0.2f like that, and there you go. You're also going to be able to use exponentation. So let's throw this inside. Whoops, throw this inside of here. Actually, because that semicolon there is there, that would be completely legitimate if I would want to do that. So there we go. Sorry, I got an itch. That's the sort of stuff I normally edit out whenever I'm making videos. And of course, we could just come in and go like this. And let's go and just change. Well, that already is that's a thing already. So, whoops, I accidentally put this in there 2 times. All right, so let's get rid of that. We're also going to have modulus, and to perform a modulus operation. Well, if you want the 2 or the percent sign to show up, you put 2 percent signs inside of your string, and then afterwards the mod operator for modulus is just mod like that, and 5 divided by 4. And if you don't know what modulus is, it gives you the remainder of a division. That's pretty good. Let's go and run that. You can see all those working, and there is all of those different operators. And the reason why you have to double up the percent signs is because it's a protected, piece of code. All right, let's see, boom. Okay, so what do we want to do now? Well, we're going to, let's say a lot of things you're going to need to do is generate random values. So let's say I want to generate a random integer, and I want it to have a value between 10 and 20. So we can just go 10 and 20 exactly like that, close off those 2 parentheses, and run it, and you can see that we're able to get a random value of 18, and there it is 16. Okay. And what else would we like? Let's take a look at precision, and let's get rid of all this stuff here because it's sort of clouding everything up. Because it's important to understand what precision you're working with whenever you're working, especially with decimals. So I'm going to just go like this, and 1, and how many do I want? Basically, we can trust we're going to have 15 digits of accuracy, and here I'll prove that. So I'm going to go. Okay, so that's 16 ones. So let's just throw that inside of there. Thank you very much, Glitch. I greatly appreciate it. That is super cool. I really do appreciate it. I'm not just saying that. All right, so let's go and throw this inside of here. And let's do another one. So I'm going to call this BF2. And let's go and change this to 0 just so I can show the precision that we're working with inside of Octave. And yes, everything is exactly the same on every single operating system. I'm using Windows, but you can use anything that you would like. So I'm going to go and output this. So BF2 is equal to, and I want to have 16 digits of precision that show up inside of here. So how I'll do that is go 0.16 and F and a new line, exactly like that, and throw BF2 inside of it. I think I got everything right. And here you will see a demonstration of, whoops, what did I do? I typed BF2 somewhere. Oh, yeah, I did it right there. BF2, whoops. Oh, I accidentally hit my caps lock on my keyboard. See, one of these wonderful things you get to experience in a live stream. Oh, wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Well, that was actually supposed to be messed up. Actually, the whole doggone thing's messed up. What'd I do wrong? Oh, I see what I did. I should have did this and equal to B and F plus. That's what I meant to do. So let's do that again, and let's run it. And here you can see that we lost our precision here with the very last digit. If you continue adding digits, you're going to continue losing precision. So very important to be aware of, how accurate our code's going to be. Let's go and do a rundown of some different other mathematical operators because you will be using a lot. And what I'm going to try to do next week is almost borderline insane. I used to work as a, just as a side project, a tutor in calculus. And what I found, because believe me, you're going to need calculus if you want to learn machine learning. One of the problems is every single time I would ever get a student that would show up for tutoring in calculus, they used to always be surprised because I would walk in and I would say, okay, here's our book. And I would slam it down on the table, not too loud. And it was an algebra book. And the kid would always look at me and they would say, what are you talking about? I'm here for calculus. And I found that almost every single time, the reason why people struggled with calculus is because they didn't really understand algebra. And so what I'm going to try to do next week, if at all humanly possible, is I'm going to try to teach on this day, next week, same time, same thing. I'm going to try to teach Algebra 1 and Algebra 2 in one video. I'm just a little crazy. I'm going to see how it works out, and I think it'll work, as long as I don't lose my voice. I very well might lose my voice. All right, so let's say you wanted to do an absolute value, and it'll be all the hard stuff. That's what I'll mainly focus on. I'm not going to spend an hour solving variable values and things like that. I mean, it's mainly going to focus on the stuff that I know people that are preparing for calculus really struggle with. Okay. So what am I going to do? Absolute value, and this is going to be an integer. I'm going to say new line like this, and if you want to go and get the absolute value, just go absolute value like that, and let's just throw, I don't know, -1 inside of it, and close that off. And after this video, this is going to go on YouTube tomorrow, so you can get that, but I'm going to put all the code that I have here, but it's going to have a lot more comments, and I'll make that available to everybody on GitHub. And there you go, absolute value, we calculated it. And let's get rid of that. And what else do we want? Well, I'm just going to go through some of the basic operators. I'm just going to copy and paste these in here so you don't have to watch me type them in. So let's do something like floor, and we'll throw 2.45 inside of here so you can see how that differs. And this operator is actually called floor. So we'll throw floor inside of there, 2.45. And maybe we want to copy this one also. So I'll get this, paste that inside of there. Let's also do ceiling. So ceiling like that. And we'll leave 2.45 inside of there because that works. And there is ceiling. And I also can just do round. And basically the difference between floor and ceiling is floor is always going to round down, ceiling's always going to round up, and round is going to round up based off of whether this is 5 or not. All right, so that's the main difference between all of those different guys. So this is round, and there you are. What else would I like to do? Let's try exponents. So we'll do like this and 1. And whenever I got that sub, I thought I was supposed to have like a little thing show up here. I guess it didn't show up. That's kind of silly. Okay. Distracted there for 1 second. Let's go exponent again, and 1. And what else do we want to do? And this is, if you're wondering, e to the power of, you know, whatever is placed inside of it. Let's do another one. We can do logs also. So we'll do log and 100. And so there you go. And this is just going to be log 100. Very easy to understand. You don't have to use any type of specific class-based stuff or anything like that to do all of these different calculations. Let's throw another one in. We could do log 10. There's multiple different log operators inside of here. I'm just covering the most common that you would ever have to deal with. So we'll do log 10, and maybe we'll change this to 100 as well. So 100 and 100, like that. And you could also do log 2. You could, you know, I'm just going to stick with what I got here. I'm going to do square root. Let's make that 100 also. and square root 100. And get rid of that, get rid of that. There we are. And what else would we like? You can also convert degrees into radians. So let's throw that down there. And let's go and we'll just change this to degrees to, and I'm just going to say rads. And this is going to be a float in this situation. And you don't need to define the decimal places if you don't want to. And this is really simple. You just go degree to rad like that. And we could throw 90 degrees inside of there if you wanted to do that. So there we are. And we can run it. Don't think I made any errors. Nope. And there you can see all of the results that we received are completely understandable. And there's a whole bunch of other math operators that I'm going to cover as we continue onwards here. Let's just get rid of this so that we don't have to look at it. All right, now we get into conditionals. Conditionals are very easy to understand. The only one change from many common languages is it's going to use a tilde here instead of a not equal. Other than that, you know everything else, I'm guessing. If you're watching an Octave tutorial, I'm not going to waste your time. I assume you know this stuff. Of course, this is or, this is and the tilde represents not. Have to get a drink. All right, so I'm going to say age is equal to 12. And then what I'm going to do is I'm going to say if age, just to demonstrate exactly how these work, is greater than or equal to 5. And age is less than or equal to 6. I just thought of it. Everybody that is here right now, I have done unheard of number of learn-in-one videos. I don't even know how many. Probably over 100 or 150. This is the very first one I've ever done live. So you're watching the very first live learn-in-ones. And as far as I know, I'm the first person to ever make a learn-in-one. Because the week that YouTube allowed people to make videos that were an hour or longer, I made one 3 days after that announcement, and that was my C++ video, which is pretty popular. Okay, so we're going to say if age is greater than or equal to 5 and age is less than or equal to 6, then we're going to say display, and I'm just going to use simple display here, and I'm going to say you are in kindergarten. Okay, so this is basically just going to place people into the correct school based off of whatever their age is. And then we can do else if, which is actually spelled out. So we're going to say else if. And then we can just simply follow that up with age is greater than or equal to 7. And age is less than or equal to 13. Well, in this situation, and you can see it automatically indents here inside of here, we can come in and we could say you are in middle school, like that. And then we could do another else if, and we will say, and let's go and move this back. For some reason, it doesn't register whenever I add another else if. Like I said, it's not the greatest interface for coding, but it's pretty cool. So I'm going to say age is greater than or equal to 14. Hello Dallas. Thank you for visiting me. It still doesn't make sense. After I've been doing this for 13 years, and I still can't believe that people watch my videos all over the world. Now, obviously, Dallas isn't that far away, but I wish I had your weather. I know that much, because it is ridiculously cold here. Actually, today is not that bad. It's 45. That's a heat wave where I'm at. We've been in the freezing temperatures lately. So I'm going to say you're in high school. And then you could do as a default, else I'm not going to bother bringing that tab back. We'll say display, and we'll just say stay home. Okay? So a semi-useful usage of a if-else statement. And you have to always end it with an end statement. And if we run it, you're going to see you're in middle school. And of course, well, there should also be one here that for a person that's under 5, but I didn't put that in. So there you go. You get a basic example of how to use conditional statements in multiple different ways. What else would I like to do? One thing that's important is you can go true, and we'll do an or statement. You know what? I'm going to do it. You could do it here, but I'm going to do it over in the command window just because it's more useful. So I'm going to say command like this, and where is that on my keyboard? I'm mental. Okay, and false like that. So that's the or statement, of course. And also you have the tilde or the not, which is true like that. So, and you can see all the falses turn into zeros and all the trues turn into ones. Anything else? Well, we'll talk about the switch statement. Octave has a switch statement. So we're just going to go switch and age. And this is kind of cool. So what we can do here is we can say case 5 like that. So case, the age has the value of 5. And then we could, you know what? Why even bother typing this back in again? We're going to say you're in kindergarten like this. Let's go and copy that. So got that. And we'll just put it right there. So there you go. And then you're going to be able to actually be able to do ranges as well, which is very useful. So we can say in this situation, I'm a stickler for spaces. Okay, so if you want to do that, we can say num2 cell. You can see num2 cell pops up inside of there, and we can just simply say 6 to 13, exactly like that. So very useful. In this situation, you're going to say you're in middle school. So I'll just copy that and jump down here, paste that inside of there, and there we go. And likewise, we could also do a list of numbers. So we could say something like 14, 15, 16, 17, and 18. Why not? Throw that inside of there. And in this situation, you're going to say you're in high school. So we'll copy that, jump over here, paste that inside of there. Anything else I want to do? Well, if you do not have anything else, instead of using default for some reason, Octave decided to use otherwise as instead of default, which is fine. And in this situation, you would display stay home. So there you are. Paste that inside of there. Come down here. And you always have to end everything. So let's run it. And you're going to see you're in middle school pops back 2 times. All right. So exactly what you would expect. And people always ask me where I live at. I live in Pittsburgh, Pennsylvania in the United States. So just in case anybody has any interest, there you go. All right. Vectors. So we will be using a lot of vectors and matrices when we are working in machine learning. So it is extremely important to understand how they work. Now you're either going to have row vectors or you're going to have row vectors or column vectors. They're exactly what you think they are. So I'm going to come in here and I'm going to define a vector. Did I delete all this stuff? I should delete it. So I'm going to come up here and I'm going to get rid of all of it. So I typed all that in, and in one dash, it is all gone. All right. So whenever we're talking about vectors, to define them, you're just going to say equal to, and let's say 5, 3, 2, and 1, like that. But of course, you have to put spaces between all of them. And let's go and run it. And there you can see. And this is what we would define as a row vector, because that's what it is. Have to drink, otherwise I will lose my voice. All right. So if you want to find out how many, let's just go and throw a semicolon in there so that doesn't pop back. If you want to find out how many elements you have inside of your vector, you're just going to type in the length, and you can throw in, what is it, VT1, exactly like that. And that is going to show you your length for your vectors. You're also going to be able to sort your vectors quite easily just by sort is equal to, and VT and 1. And what else would we like to do? Maybe we want to go and create a range for our vectors. So I'm just going to come in and we can just say 5 to 10, exactly like that. And in that situation, I'll let that run. And you can see that we went and generated 5 through 10, not 5, not including 10. So that's important. All right, so we went and created that range. And I'm just clearing this to try to keep everything clean. One thing that's really weird about the Octave GUI that I'm using right now, I normally use fonts that are considerably bigger, like 30-point fonts, and 24 is the max. I don't understand what they were thinking. I guess they weren't thinking anybody was ever going to do a tutorial for some reason. Or they don't realize people have bad eyes. All right, so you can also create ranges in steps. So let's say we wanted to do 2 through 10, and we wanted to have a step of 2. We can do that as well. And just, I'll run it here in a minute. You're also going to be able to concatenate vectors. Am I on a rights thing? Yeah, I am. All right. If you want to concatenate vectors, let's say we wanted to create a new vector, VT4, and you wanted to make it up with VT1 and VT2. That's all you need to do, and everything works. What else would we like to do? If you wanted to get like a specific value out of it, you could use indexes, and we could just go and say we want index 1. And let's just go and run it. So we're going to see here VT4. This is our concatenated vector we just created. And this is going to be indexed with a value of 1. So that's what you'll get in that situation. Let's throw 0 inside here and run it just to see what it does. You get an error. See? I had forgotten what happens if you do that. So it's not a 0-based index vector system. It is based off of 1, which really makes a lot of sense in this situation. All right, if you wanted to get the last value, so we'll say VT end, you could just say VT4, and take a wild guess. What do you think would be the absolute best thing I could type in here if I wanted the end value inside of a vector? If you guessed end, you are indeed correct. What else would we like? Let's say you wanted to change a value. Very easy. So we could just go VT4. We're not going to use the brackets like are common in pretty much every single programming language. We're going to use parentheses, but really not a problem. And in this situation, let's say we wanted it to be equal to 12. That's how you would do that. If you wanted to add a value to the end, you could just say VT and 4. And we could go and do, let's say we wanted to do 11. You could do this. Or you could also just type in end and also be able, well, the end would just overwrite the last value inside of there. Let's say you wanted to be able to get a group of values. So you wanted to be able to get a slice of values, however you want to say it. You could go and just put that inside of there like that. Hello, thank you for stopping by. Don't know what your name is though. G76. All right, I'll just call you G76. Okay, what else do we want? Let's say you wanted to get the second, the fourth, and the sixth value out of your vector. Could you do that? Yes, you can. You can say VT4 like this, and then, it's going to be like this, and then you're going to type in, what did I say, 2, 4, and 6? Good morning, visitors. Thank you for stopping by. I greatly appreciate it. It's 12:48 currently, where I live. What else? You could also, well, we've been talking about row vectors the whole time. We also, of course, can use column vectors. And how you create a column vector is you just put semicolons between all the values, and all of a sudden, magically, it becomes a row vector. So we can just go 2, 3, and 4 like that. Don't need to do anything else. And if we run that, you're going to see, look at that. Magically, now it is a column vector instead of your common row vector. Oh, okay. I get it. No problem. Yeah, it's cool how so many people all over the world watch my videos. It really is impressive. Let's say that you wanted, let's go and create another row vector here just to do some other interesting things. Let's go 1, 2, and 3. We can also, of course, do vector multiplication, and it works very easily. You can just go vector multiplication is equal to, and VT 5 times, and VT 6. We can do both of those, and we can run it. And you can see here is our vector multiplication between those two vectors. And if you don't know linear algebra, basically the way this is going to work, so if we have 2, 3, and 4, and 1, 2, and 3, and we multiply those vectors together, let's bring that up here. Basically, what is happening is you're going to get 2 times a1, and then you're going, this is the 3 values. So where did this come from? This is 2 times 1, and for, maybe I should not put a space between these. So the first value across the top is 2 times 1, and then you're going to have 2 times 2. That's where the 4 comes from. And then you are going to have 2 times 3. All right? And then for your next line of your code that you work with, you're going to have 3 times 1, and then you're going to have 3 times 2, and then you're going to have 3 times 3. Okay? So you're going to take these one by one and multiply versus all of those different values. So take this, and that multiplies times all of these values. So that's the first row, and then you're going to take and multiply all these other ones. So this one right here multiplies times all those, and then if I continued, it would be 4 times all those different values. So I'll get into linear algebra at some point. I'm probably going to make a learn linear algebra in one video, which should be insane. Next week at this time, I'm going to teach which language is this? I'm using Octave is the name of it, and it is often a language that is used in scientific community for doing mathematical work, and also it's very commonly used as a basic language for those interested in machine learning. So that is what Octave is. It's basically a clone of Matlab, except it's free. And if you want to get it, just type into your search engine Octave GUI, and that will give you exactly what I have here, 100% for free. All right. What else? Oh, well, you can also do a dot product. So let's go and create another. We'll just call it VT7 just for the heck of it. And I'm going to say 4, 5, and 6. And I keep seeing things out of the corner of my eye. What you're going to need to do, however, is you're going to need to transpose a vector. And that just means if it's a row vector, you're going to flip it, and it's going to become a column vector. And if it is a column vector, you're going to flip it up, and it's going to be a, well, I'll just show you, okay? Well, why am I sitting here talking whenever I can show you? Okay, so we have 4, this is a vector here, 4, 5, 6, and this is a row vector. You know it's a row vector because there's no semicolons between it. And I can just go VT7 like this, and you're going to put a single quote like that and run it. And you can see here it is a row vector, 4, 5, 6, and then if we get the transpose of it, we're going to get 4, 5, 6, but it's going to be as a column vector. And that is very important in machine learning, but it's also extremely important in linear algebra in general to be able to perform these calculations. And you could not perform a dot product calculation without the ability to transpose vectors. It's just the way it works. All right, so if we wanted to get our dot product for this, let's just call this VT and dot product like that. And we can go VT6, and we just multiply times VT7, and then we put a single quote inside of there, and that is going to give us our dot product. Let's go and clear this though first, whoops, so that maybe we can get a little bit of stuff off the screen, and we'll run it, and here we're able to get our dot product. You're wondering, well, what exactly is going on with a dot product? I don't understand that calculation. Well, that's perfectly fine because I do. All right, so what we're going to do with the dot product in this situation is we are going to, well, first off, we're working with we're working with this vector 6 and the transpose of vector 7. Vector 6 is right here. Vector 7 is right here. Now, the way the dot product works and how it gives you one value instead of multiple different values is it's going to have 1 times 4, like that, and plus, and 5 times 2, plus, and 3 times 6. And if you perform all those different operations, you get a value of 32. So what is it doing? Well, it's taking this value right here, and it's multiplying it times that. It's taking this value right here, multiplying it times that, this times 6, and then it is summing all of those. And that is the dot product, and yes, indeed, it is very important to understand how to perform those calculations. This is a row vector. This is a column vector. You can't perform multiplications unless your matrices have the same. So what this would end up being, we have 1 row and 3 columns. And what's this? This is 3 rows and 1 column. Maybe I should explain this better. Okay, so you can't perform a multiplication on matrices unless the central values are equal. All right, so what did we do? We took VT6, which is this guy right here. And what is VT6? Well, it has 1 row. We always, whenever we're talking about matrices, we always talk about rows first. I thought I typed that in there. Okay. Let's go. So VT6 is a 1 by 3 matrice. And then you have the transpose of VT7. And the transpose of VT7, remember I said you just flip this row vector, becomes a column vector. Well, what would it be then? Well, it would have 3 rows and 1 column. So times, let's bring this over here. Okay, so this is going to be 3 by 1. Cannot perform a multiplication unless this value right here for your matrix, the number of columns, is equal to the number of rows in your other matrix. And it tells you exactly what it's going to output. It is going to output a 1 row and a 1 column vector. So you know that you're going to get 1 value. Okay? So that is how matrix, well, that's the way calculating dot product with matrices works. You can also, if you want to save yourself some time, there is a built-in dot function. I just thought it was important to sort of explain that because understanding these basics of linear algebra is ridiculously important. If you want to learn machine learning, you have to start off understanding the math. There's just no other way of doing it. So you can just use the dot function like that to get exactly the same value. See, 32 and 32. I just took you on the long way home. All right, another thing is you're going to have something called the cross product. To be able to calculate that, let's go like this, VT cross. You can just simply come in and say cross like that. And you're going to VT6, and I'll show you exactly how the cross product calculations are done here in a minute. So you can just like this and save it and run it. And you can see here that they come out with a -3, a 6, and a -3. I'll show you in 1 minute exactly how I make that calculation. Because first I want to show you how to create linearly spaced vectors. So let's say we wanted to have values between 1 and 20, and you want to define a certain equal amount of space between those different values in your vector. You can go linear space like this. I'm going to say 1 through 20 and 4. And we won't put the semicolon because we want to see the output. There it is. And you can see that it generated 4 values, and they are all equally spaced. So that's what it does. So 4 values between 1 and 20, equally spaced. Okay, so whenever you're calculating the cross product, this is how it's basically going to be done. We're going to the 1, 1 value. Okay, so where is it? Yeah, so you're going to have -3, 6, and -3. And we're working with VT6 and VT7 in this situation. I have so much junk going on here. Let's get rid of some of this stuff. So let's get rid of all this. Sort of junking up the screen. It might make it harder to understand what's going on. Okay, so let's run it again. And do a CLC like that. Whoops, what did I do? Oh, CLC, there we are. And let's run it again. So here we go. And we have VT6 and VT7 right here. So 1, 2, 3, and 4, 5, 6. Now, the 1, 1 place inside of here is just going to be the A2 times B3. It might be easier just to work with this. So A2 times B3. And then you're going to subtract from it A3 minus B2. All right? And then you're just going to, and you can see exactly what those values are. So it's going to be the 2 and the 6 and minus the 3 and the 5. This is starting to become a linear algebra tutorial. I don't really want it to stretch into that way. I'll make a separate video on it. And if you want to, if you really want to, I will just tell me. I want more information about cross product. If you do, I will paste a video and you can watch that very specific thing. All right. So what else would we like? Well, we could also do logarithmically spaced values, and because I made a whole entire video on dot products and cross products and all the products. So, you know, we could go log space, and we'll go 1 through 3, and we want them to be equally spaced by, or we want 3 values, and there you can say pretty simple: 10, 100, 1000. And I think that's a good overview of just vectors for now. I'm going to get more into some other different examples, though, as the tutorial continues. But now what I want to do is talk about matrices. And we talked about matrices briefly, kind of, already. If you want to, basically, the difference between a vector and a matrice, could you paste the video you're referring to? Yes. Give me 1 second. Let's see. Where is it? Not that. Sure, I will paste it. So cross product. Let's. I think I can. I just said I can do something that I'm not actually positive. Like, oh, look at that. I can. I am delivering today. Look at me. So if you want a whole entire video, 11-minute long video on nothing but cross product, you are in luck. I made a pretty big linear algebra tutorial already. Let's do this like this, and there it is. So there it is. There's the YouTube link, and it is 11 minutes of nothing but cross product. And I actually solved them by hand. So it's not like in a computer or anything. I think learning things by hand is actually a better way of learning them. At least, except it really can't hurt, can it now? Any other videos I should watch for refreshing myself? Not really. Next week I'm going to do Learn Algebra and Learn Algebra 1 and 2 in one video, and the week after I'm probably going to be Learn Trigonometry and a little bit of geometry in one video, and then the week after that I'm probably going to do something with calculus in one video, like all the calculus you need for machine learning. And then after that, I'm going to jump 100% into nothing but machine learning. So you really don't need to watch any other videos unless you want to. I mean, it's always there. All right. So let's create a matrix. How do we do it? Well, pretty simple. We could say we want our first row to be 2, 3, and 4. And do you have a syllabus? Not real. I mean, I kind of just told you what I'm going to be doing for the next month. And it's just what I'm going to do for machine learning is, I talked about earlier in the video, for the last 2.5 years, I have been personally answering questions from people about the machine learning courses that are currently available that a lot of the universities have put out there. And I get them all the time. Like every other day I get another question about these courses. And now while these people are brilliant human beings, way smarter than me, very often people that are really smart, I have found, they have a tendency to sort of gloss over ideas. So, for example, they'll say, well, this is calculus, and they'll look at you as a beginner who uh, doesn't know things and doesn't really need to know them. And so what they'll do is they'll be like, well, if you don't understand calculus, you don't really need to. Just understand that this works, and let's move on. Well, the problem is 10 videos later, it's almost like they're so smart that they forgot that everybody doesn't know high-level multivariate calculus, and they start talking about calculus, and people are like, what? This doesn't make any sense. And then they drop out of the course, they give up on it, and they stop learning about machine learning because they're like, oh, this is just too hard for me. Let me tell you, if I can do it, anybody can. So what I'm basically going to be doing is I have a laundry list of questions that people have about those courses. I'm going to be reteaching a lot of, I'm not going to steal their content, but I'm going to be reteaching a lot of the core ideas over the next couple months. And I already have a list of questions that people have, and I'm going to answer those questions as I teach the stuff. So whenever we get to the part that is calculus, I'm not going to say, don't worry about it, just move on. I'm actually going to teach the calculus, and which isn't hard. It just takes an extra 5 or 10 minutes to teach it so that you 100% understand it. And like I said, I very often teach on paper. So at the end of this video, I'm going to actually solve the very first machine learning problem from the Andrew Ning course, and I'm going to solve it in 3 ways. I'm going to solve it on paper, I'm going to solve it as a for loop, and I'm going to solve it using matrices. That's at the end of the video. So that's what's coming. Control yourself. It's something to get real excited about. But I think it's the way to teach. I really do. Okay, so if you want to get the number of values in a row, guess what? Can anybody remember what we use? Begins with the letter L. Length. Okay. Nobody actually typed that in, did they? No. Okay. Length, and we can just do M1. If you wanted to get the total number of values, let's go, maybe I'll call this M and V, and you just type in number of elements. That's what that stands for. If you're wondering what that stands for, well, now you know. If you wanted to get both the row and the column size, you just type in size, and you can get both at the same time. What else would you like? If you wanted to store the rows and columns in different variables, you can also do that, which is neat. And how you do that, it's a sort of a trick. You go n and rows and n and columns, like that. And this is going to be equal to, and we could just go and get size, and it's going to automatically transpose those values into those specific variables. So that's neat. Let's say you wanted to generate a random matrix. Well, let's go matrix 2 like this. And what I want to do is I want to generate a random matrix. It's going to have 2 rows between 10 and 20. All right, so we're going to use random I, which is going to generate integers for us. So we'll do that, and I'm going to say 10 and 20 like that, and 2 like that, and there's a whole bunch of things. Let's run this just so you can see what it looks like, all the different things we did. Do I have stuff up here printing? Let's get rid of all of our vector stuff because we do not need it anymore. And if I'm wrong, I will just put it back in later. Okay, I don't think I'm wrong. All right, so there we go, and we'll run this. We'll type in C like that, and now we will run it. And you can see the output. So there are our matrices. You can see this is the first row, like I said. Second row, like we had there. How many elements are in the first, or in a row? Well, you can see that comes back as 3. How many total elements? That comes back as 6. What's MS? That's going to give us our number of rows and our number of columns. And you can see also that we got those stored in different variables. And then we went and generated random matrices. And of course, if we go and run this again, you're going to see that these are random once again. And there we are. Okay, what else? I have to get another drink. So yes, I do not have a syllabus currently. As I get one, I will. But what often happens is as I make ridiculously multi-month long tutorial series, you guys eventually jump in and start saying, hey, you covered this briefly and I don't understand it. Can you make a video just on that topic so I understand it? Then I start making additional videos that I originally didn't expect to make. All right. Oh, what else would we like to do? With matrices. We're going to do a lot of stuff with matrices. Okay, so let's say we wanted to use a row and then a column to get a value, which is quite simple. So we're just going to type in that we want row 1 and we want element or column 2. So let's just go and run that, and you can see that, yes, indeed, we got that. So this is row 1, and this is column 2. That's how we got 18 out of that. What else would we want? Let's say that we wanted to change a value. Well, we can just simply say M2 like that, and let's change that exact same element into 22, for example. Let's throw a semicolon there at the end of that. Let's say that we wanted to change all our row values. We could do that also. So we can say M2 like this, 1, and then you're going to put a comma and a colon. That's going to refer to all of them. And you can change that to 25. And if we run it, you can see that we were changing the entire row to the values of 25. And if we change this to 2 like this, well, we're going to change the second row to 25. So all of those work as would be expected. Let's change this back to 1, though, just to make sure. Okay, what else would we like to do? Let's say we would want to change all our column values. We can also change our column values just in almost exactly the same way. Instead, you're going to put your colon first, and let's say we wanted to have the first column all changed to the value of 36. That would work. Let's say you wanted to get the first value in the last row. There's multiple different things we can do. So let's call this MR1 and last. You can say M2 and end and 1. We could also go and get, let's say, so I wanted to get to second value. Let's say we wanted to get to the second value in the last column. So I'm going to call this MR2 and last. And we will come in and, whoops, M2 and 2 and end like that. And we can get all of those values as well. So numerous different ways. Let's say we wanted to delete a column. Well, we could go M2 and we wanted to delete the second column. Remember, if you want to do things with the rows, you're going to have your values in the beginning before the comma. If you want to do things with columns, you're going to have your value in the second position. So what we want to do is we want to delete the second column. So we do this, and there we are. We deleted it. What else? I think that's basically it. That's a lot of stuff about matrices. And I think now what I want to do is jump into looping. Of course, you can see this says matrix functions, so we're going to get back into working with matrices, though, in a minute. All right, so there's a rundown of all of these multiple different ways of working with matrices. And like I said earlier, my GitHub page is going to have all of this code for download with a ton more comments after my video's over. If you want to know where that's at, let's see. Not that one. There it is. My GitHub page, I'll post that right here. GitHub. It is right here. And then all you need to do is go to this page and look for Octave. Okay? So I'll just put this here. Paste. Boom. There you go. And Octave is going to be in there sometime after I make this video. So in an hour or so. After I go off the air, of course, because I can't do it right now. Yeah, I just paid Apple money. Isn't that nice? Okay, so let's go to looping and how looping works. So let's do a for loop. So what you can do is just say for I is equal to, and we can do 1 through 10, and you don't have to do curly brackets or anything like that. You just do this. I'm going to use the simple display function because I don't need to format anything, so there's really no reason to do anything else. And we can go and say that we were outputting 1 through 10. Very important to understand that it's going to go up and also include 10 with our output. So that's the basics of that. We're also going to be able to decrement and step and do multiple different things in that regard. So let's say we wanted to go from 10 and we wanted to decrement by 1 to 0. We could do that. Oh, get that out of there. And we'll just copy this part right here because it's exactly the same. So paste that inside of there. And you can see that we're going to be able to count down from 10 the whole way to 0. And there you go. There's another way of working with for loops. What else could we do? We could also we could specify specific values that we wanted to cycle through. And also on top of that, we could use, say, a vector in this situation. So what I'm going to do is say 2, 3, and 4 like that. And then we can just say, do I still have the display? Yes, I do. I still have the display part. And you can see here, it's just going to cycle through that list. And let's say that this was some vector or something. You could also type in VR1 or whatever inside of there. And there we are. So that would work also. Just numerous different ways of working with that. Why don't we cycle through a matrix? Because I think that's probably more complicated. So let's create a matrix here. And it's going to have rows. And it's going to have 2, 3, and 4 inside of here. And 4, 6, and 8. Whoops, you have to put spaces in between those. 4, 6, and 8. So there is a matrix. Now, how can we cycle through it? Well, we can cycle through it with for loops. So we could say something like for I is equal to 1, 2. We could also use size to determine how many rows are inside of each of these or whatever you would like. All the stuff that I showed previously. Best way to learn a language, like really understand it, is to take the stuff that I cover here and then just sort of play with it and be like, oh, I wonder if this works. Okay, then what we just need to do is put I and J inside of there. And there you go. And then, of course, you're going to need to end both of these for loops. So end. It's really cool that a language like Octave actually exists because otherwise you'd have to pay for Matlab. And Matlab is extremely expensive. And Matlab is a very useful thing to know as well. So there we are. We were able to cycle through all of those different values in our matrix. I'll show you how to cycle through our vector also. So let's say we have 6, 7, and 8. Exactly like this. Whoops, like that. And we could go for I, and then we're going to do 1 and length I, and yes, I got that right. Oh, this is going to be for I is equal to 1 through the length of I vector. See? Remember I said that you'd be able to actually use the length of the vector to determine how many spaces and so forth to type in here. And then we can come in and just simply say display I vector, exactly like that. And then throw I inside of there, and you're going to be able to also get the values that way. So, pretty neat stuff. There we are, and end. Okay, now we can run it just if you want to see what that looks like. Of course, there we went and output all those different values right there on the screen. Another thing, what would we like to do? Oh, well, we've covered numerous different ways of working with for loops. Let's talk about a while loop. Now, with a while loop, just like with every other programming language, you're going to have to define the value you're going to be using within it outside of the while loop. So in this situation, I'm going to define I is equal to 1. And I'm also going to show you how continue works and break. So let's say that we have while I is less than 20. So we're going to be cycling through 1 through 20. What I'm going to do here is I'm going to say if, and I'm going to use modulus I and 2, if it is the modulus of the value is equal to, whoops, there we are, equal to 0. Well, in that situation, we know it is an even value because the modulus of an even value divided by 2 is always equal to 0 because there's no remainder. Well, in that situation, I want to display that even value. All right, pretty simple stuff. One thing to know about Octave is it doesn't have plus plus and plus equals and stuff like that. So just something to be aware of. Then what we can do is we have to increment, of course, the value of I. I think Matlab actually does. I might be wrong about that, but Octave does not. Okay, so we need to increment this value, and then at this point we can use the continue statement. Continue statement is just going to jump back to the top of our loop. If you probably know that, that's what it does. And I'm going to have to get some more water here very soon. Okay, so what we can do in this situation, we have to close our if statement, and then let's move it over just so you can see that that actually closes the if statement. There it is. And then we are going to increment the value of I again. So increment that. And then let's say that I wanted to jump out of this while loop anytime we have a value of I greater than or equal to 10. Well, what I can do is I can say if I is greater than or equal to 10. In that situation, I want to leave the loop. So I can just say break, and there you go. And that's going to jump to the exact first line after the while loop ends. And where does the while loop end? Well, it's going to end exactly right here. And there it is. And that is how that's going to operate. And if we run it, you're going to see that we are able to print, this is it, 2, 4, 6, and 8. And that's how we cycled through all those and printed all of those different values. All right, let's do some matrix functions. And then I'm going to run and get water because I am dying of thirst. I'm drooling on myself. Okay, so let's create, I'm very classy. Let's create another matrix. And this is the problem with live streams. 2, 3, and 4. This is going to be the first row. Then we're going to have 4, 6, 8. Whoops. Make sure you put a space. 4, 6, and 8. 8, 12, and 16. And 16, and 24, and 32. All right. So there you have, this is row 1, row 2, row 3, row 4. All right, so there is our matrix we're working with. Now, you can add and subtract these. So let's say we have M4, it can be equal to, whoops, is equal to, and we can go 1, 3, and 4, 6 for these guys. Let's come over here and go like that and run it. And there you go. Whoops. Put all those extra values inside there. I don't think I need those. Let's get rid of this. I don't believe I'm going to use this anymore. Nah, I'm definitely not using these looping things. So let's get rid of it because it's just clogging up my command window, and I don't like that. Okay. Whoops, accidentally. There we are. All right, so let's run it again. And you can see 1, 2, 3, 4, 5, 6. All right. So that is going to generate those different values. What else would we like to do? Let's go and make basically another one here. So I'm going to go like that. Oh, you know what? Yeah, that's fine. Spilling water all over myself. All right. So let's go. Guess why? The reason why this didn't print as a matrix, because I didn't put a semicolon. See, I originally put a comma. No, you need a semicolon. All right. Boom. Now it's a matrix. All right. So good stuff. So let's go and let's create another one. We'll call this M5 because that's a good name. So what we can do here is we can do a range between 2 and 4. You can do anything you want. And then we could do a range between 5 and 7. Exactly like that. And if we run it, you're going to see that now we have 2 matrices created. Now you're going to be able to add these matrices quite easily. I can just say, actually I can jump over here and do it. So we can go M4 plus M5 like that. And that is going to add the matrices. And it's very easy to add matrices. All you do is take this value and add it to this value. And you can see that's exactly what it looks like. All right, so while dot products and cross products and all that stuff is a little bit more complicated, a little bit, adding and subtracting is extremely simple. You're also going to be able to multiply them. So we can say M4, you need to go, whoops, I was in the wrong thing. Well, we can just do it here also. Now, let's just do it over in the command window. Very often, it's very easy, way easier to do things in the command window. So let's say we want to multiply them. There you go. We just multiplied them. Of course, 1 times 2 equals 2. 2 times 3 equals 6. All right, pretty simple stuff. There's also multiple different, you can also use functions just as you would do with numbers, but you can use matrices instead. Let's just play in the command window over here. So we could do like the square root of M3, like that. Whoops, I keep typing in the wrong window. Well, let's just cut this out of here and paste it over here. And you can see we're able to go and it automatically knows to perform that same function on all of those values. So very useful. We're also going to be able to multiply all of these different values. So we could do M3 times 2, and you can get the multiplication of all those different values by 2. And pretty neat stuff. You're also going to be able to sum all these different values. So let's say we wanted to do a sum of those matrices, whoops, sum of the matrix values. And you can see that we went and summed all of the different columns to get all those different values. And like I told you before, anytime you're multiplying matrices, you have to understand that, let's say if you had 3 rows and 1 column, well, you would need to multiply them in a way so that the center values are equal. So you can only multiply this times something that would have 1 row and by, I don't know, 2 columns, okay? And if you did, what would your matrix be? Well, it would be a 3 row by 2 column matrices whenever you perform this multiplication. And if you change this into 1, well, it would be a 3 by 1, okay? And that is how matrix multiplication works. So let's go and create another matrix here. Let's call this M6. And I'm going to go 1, 2, and 3. Another thing you can do, you can go to the next line if you'd like and continue typing these in if that makes it easier to understand. And Octave automatically just figures out what you're doing. So let's go and create a couple more matrices. So I'm going to go call this M7. I'm going to have just a whole bunch, whole bunch of 1s across the top of this. And then I'm going to have an equal number of 2s across from that. And then an equal number of 3s after that. And what else? Well, let's go and calculate this. Let's say we have M8 is going to be equal to M6 times M7. And we can run it, and you can see how those different calculations were made. And basically, it's just the 1, whatever is in the 1 index of the matrix is going to be multiplied by whatever is in the 1 matrix, the 2 by the 2, the 3 by the 3, the 4 by the 4. All right? So, very, very simplistic. Another thing, now we can get into a little bit more complicated things. Let's say we wanted to check how many values are greater than a value. Well, let's go greater than, and I'm going to say 3m and I can just plug my matrix inside of here, M4 greater than 3, and if I run it, it's going to tell me how many. And it's going to tell me by either having false or true. So it's saying all of these values are going to be equal and the other one is not. And you can see where is M4. M4 is right here. So we said greater than 3. Well, all those are false and all of these are true. Thank you very much for following, Siegfried. I appreciate it. Okay, so what else can we do here? Well, let's say we wanted to check for equality between our matrices. So we can just say is equal and plug M4 inside of there and M5 inside of here. And all this code will be on, I posted the place on GitHub where I'll post this, and it'll be up about an hour after I finish this video. And you can download it all for free. Everything will be 100% for free, except it'll have a whole bunch of comments inside of it. Let's say we wanted to multiply column values. Let's put M3 inside of here just so you can see it. I'm going to say product and M3 and run it. And we can see where is M3. There is M3. And we multiplied 2 times 4 times 8 times 16 to get this value, and so forth and so on. All right, let's continue on. Let's say we could do a cumulative sum. So that means the first row is going to stay the same, and then the next row will be the first row plus the second row, and then afterwards it'll cumulative sum, you know. So we'll do cumulative sum, and we could just plug M3 inside of it, and it would work. There's also cumulative product, and that's just exactly what you would think. Cumulative product, M3, exactly like that. All right, and let's say there's all numerous, like there's so many math operators, especially targeted at working with matrices built into Octave because it's a math tool. So let's say we wanted to flip the first column to the last column. Well, we just say flip and LR, and there you go, M3, like that. Let's say we wanted to flip rows. Well, we could say flip and UD and M3, and you can see what these look like if you would like to see them and see how they're moving around, and you can see all that. All right, so there we are. What else would we like to do? Let's say we wanted to rotate. We could actually rotate the matrices 90. You can rotate it whatever you'd like, but I'm going to rotate it 90 degrees. And you just go rotate 90 degrees, and you throw in whatever matrix that you would like. And there's multiple different situations in mathematics where rotating is very important. Now, let's say we wanted to rotate it 180 degrees. Well, you could go rotate and 90 again, and we'll throw M3 inside of here, and then we'll throw 2, which is going to be 90 times 2. And that will be able to rotate that way. Let's say we wanted to convert it into a different size. So we have our M3 matrix. I've been playing around here so much with this. Let me see. Let's see what M3 even looks like. So, okay, so here is M3. Let's say we would want to convert it into a 2x6 matrix. What we're going to do is we're going to use a tool called Reshape. And we will take M3 and we'll say 2x6 like that, and we run it, and you can see that it did. It created a 2-row by 6 column. You just have to make sure that the values work, you know, that there's enough values to make up for any type of reshaping you'd want to do inside your matrix. Otherwise, obviously, it won't work. Okay. Let's say we wanted to duplicate a matrix into 2 different matrices or into a new matrix with 2 rows and 1 column. Well, we can do place matrix and M3 and 2 and 1. There we are, and run it. And you can see there we are. So it just keeps on continuing. What else can we do? We could also duplicate elements in new matrices. So let's go repel M. There we are. And let's go M3 and 2 and 1. That. And I'm getting really deep into the weeds here, and I think that's a good understanding of exactly how we can manipulate matrices in multiple different ways. And now we're going to move into cell arrays. Let's go and get rid of all this stuff that we have here. And there we are. Now, a cell array is going to store different data types of information. So let's say we wanted to have like customer information stored inside of here. I'm going to call this customer A1. How you can do this is inside of curly brackets. Let's say Doug Smith is the person's name, and he is 34 years old, and then we have certain information about Doug Smith that is important for one reason or another. That is 25, 8, and 19. All right, so there we are. We stored multiple, make sure you end it with curly brackets. And there's multiple different types of data stored. This is called a cell array. Okay, so we can also get the information by index just by typing CA1, and then in this situation you're going to use curly brackets though. So let's say we wanted to get customer 1's name out of this cell array. Well, you can see there it is, and here we were able to pull his name out of that cell array. What else can we do? Well, let's say that we could also go and stack these. So I can go CA1 and 3 and be able to pull out the second value out of the vector that is stored in the third index. So this is a way we can refer to an index in a cell array, and then this is the way, just as we always do, is how we're able to refer to a vector in a specific index. So we can see we got the second one, and there is the second one. Okay. We can also add additional data. So let's say that we want to put some more information here about our customer. Like, for example, we find out our customer's wife's name or something. I don't know. Her name is Patty Smith. Patty Smith. And we can do that. And there is Miss Patty Smith. What else could we want to do? We could also say that we want to get the number of elements inside of here. So we can just go CA1 like that and run that. And we're able to get that. And there's 4 elements. Remember, we added Patty Smith, and a vector is only treated as one element. So that's the reason why we didn't get, I don't know. I'm not going to bother counting it. You get the point. We're also going to be able to delete different values. So let's say CA1, and we wanted to get rid of what was in index 4, and maybe poor Mr. Smith had a breakup with Patty Smith. Well, now we can update our customer information on that. We're also going to be able to cycle through this just like we do with any other piece of information we would like to work with. Now, remember, if we want to get the length of our customer information, we can just type in C and A inside of length, and that's going to give us our total number of values stored inside of there, and then we can just simply say display, and we can get whatever our piece of information is. So CA and 1 exactly like that, and then we will throw I inside of there exactly like that. Oh, no, this is supposed to be a curly bracket, so let's get rid of that part. Curly bracket and curly bracket, and since this is a for loop and this is Octave, whoops, we have to type in end like that, and let's run it. And you can see that we're able to output all of that information. And remember, Patty Smith was deleted. That's the reason why she's no longer in our database. We can also go and convert a cell array into a character matrix. So CA3 is equal to, and we're going to put curly brackets inside of here, and we'll say Doug, like that. And Patty, maybe Doug and Patty are considering getting back together again, and we'd like to store that for some reason. And name matrix is going to be equal to, and we're going to convert this into character. Very back in a long time ago at the beginning of this tutorial, I talked about how to cast from one data type to another. So we'll say CA3 in this situation and run that. And you can see Doug and Patty pop out of that little guy. What else would we like to do? Well, we could also get a character array and convert it into a cell array. So we can go CA, let's call this CA4. And you would just type in cell like that and name matrix. And there we are. And run that guy. And there you are. Okay, so pretty neat stuff. All right, so that's a lot of stuff on working with cell arrays. And now I'm going to talk about operating with strings. So strings are just vectors of characters. That's the way that they are treated inside of Octave. So let's go and create one. I have to get a drink again. All right. Just call this I am a string, like that. We can go and get our length of our string. We are going to be able to get a character at any specific index that we would like. Just string, remember it's a vector, so you're going to get access to the different indices using the parenthesis notation. Only whenever you're dealing with the cell arrays are you going to be accessing the different indexes with curly brackets. So that's how we get access to those. We can also go and get slices or substrings, which means blocks of that information. So we want 3 through 4. We can get it and we can run it, and we can see that we ended up getting am passed out to us. I, of course, was the very first index. So we're able to get slices of strings, which is also very useful. We're also going to be able to concatenate different strings or join strings. And how we do that, let's go string 2 is equal to, you just call string concatenate is what that stands for. And we can go and get string 1, and then we can define what we want to concatenate to the end of it. So I can say something like that. If you want to go and have, like, let's say you start this off with a single parenthesis and you want to have 2, you just like we worked with percent signs whenever we had to use those, well, you just throw 2 of them inside of there and everything works perfectly fine. So that's kind of a useful, nice way of working with things. And you can run, whoops, what did I do wrong? Line 120, I don't know what's going on. Let me just look. Oh, I see what I did. I forgot to put in that parenthesis that we have there. And now it works. I am a string that's longer. That is longer. Yeah, that works. Okay, what else could we like to do? Let's say we want to find all index matches for a string. We're going to use something called string find. And with this guy, we can go and define our string that we want to work with. And then we can say, like, we wanted to find the letter A, and we could get it. We can also replace all matches, and you're going to type in string replace, like that. And you can type in whatever string you want to be searching through. And let's say that we wanted to find a match for the word longer, and we wanted to replace it with the string name that is bigger. We can do that as well. We can also split strings using a delimiter. So let's say we wanted our delimiter to be any spaces, and we want to split the string that way. So I can call this string array is going to be equal to and string split, and you just pass in whatever your string is. This is string 1, and if it had commas and spaces, you would just put a comma and a space, but this guy doesn't. All it has are spaces. We can throw that inside of there, and we could run it, and you can see that they are all now in their separate little index. Anything else we would like to do? Well, you can also convert a cell array into a string. So we could do something like CA5 is equal to, and remember with cell arrays, you're going to use curly brackets. And I could do something like I like chickens. And there we are. Chickens. And I actually have chickens in my backyard. My wife has them, but they're her chickens, but whatever. And you can see they're all split that way as well. You can also convert an integer into a string. So integer string. To do that, you type int to string. And let's throw 99 inside of there. And also you can convert floats to strings. So what did I say? Convert a number into a string. Well, we can go f str is equal to number to string 3.14. What else are we going to do? Well, we could compare for equality. There's tons. I'm trying to cover literally everything you could ever imagine seeing, just simply because then you can use this as a cheat sheet and you'll never have any problem that you don't have an answer to. That's the ultimate goal with it. So I can go and there's functions to check if something is a letter. So if we have a letter inside of here, so we can go num and 2. We can check if everything in the string is a letter. And how you do that is st is string and prop. And we could go and type in something like word 2, and then we type in alpha like this, and let's run it. Well, actually, that is, see, we're going to have, this is going to come back, this is going to be alpha, this is actually checking if everything is a letter. So this comes back as true, as you can see over here, and then true, 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 and then this is actually a number. If you wanted to check if everything is a number or a number, a letter or a number, I think, then you could do this, and then you can see that they all come back as ones. What else could we possibly do here? Another thing is we can check if something is a string. So we'll say is character, like that. And again, we could say some words 2, like that. We could also sort our string. So let's say we wanted to sort it by letter and numbers and all that different stuff. Well, we could just simply say sort and string 3. If you wanted this to be, this is automatically going to be in ascending order. If you wanted it to be in descending order, you could just type in descending or descend like that, and that's going to sort it in the opposite direction. You can also go and get a string and delete all the white space, and that is going to be string trim and str1, whatever string you want to work with. You're also going to be able to convert, there's a function called lower, which is going to convert everything to lowercase, which is very useful very often. There's another one called upper, also very, very useful. And I think that is every single, at least every function I can think of off the top of my head for working with strings and multiple different ways of working with strings. All right, and we're getting close to covering almost all of Octave. Up next, I want to talk about structures. And what a structure is it allows you to create a custom data type that's going to store related types of information. So let's say we have somebody we want to store information on. His name is Doug Smith. Well, I'm going to create a structure, and I'm going to say this is going to be, I'm going to define his name as Doug Smith, and after that, remember, if I want to continue typing information on the next line, I just put 3 periods, and I can do that, and it doesn't throw an error. I can then say that the keyword for age, and or I can say the keyword is age, and his age is 34. And then I can create another keyword. Oh, thank you for following. Twitch is cool. 12445. Purchases, and let's say that Mr. Doug Smith buys 12 of something that we're tracking and 23 of something else that we're tracking, and there is that. And then we'll be able to access that data, and how we can access that data is just simply by referring to the key that we assign to the different information. So we can say Doug Smith, and let's say that we want Doug's age. We can get it. We can also later on decide that we want to add additional fields. So like we said before, let's say that we all of a sudden found out that Doug is married to Patty, and we want to put Patty into our database. Let's hope that their marriage lasts longer than it did last time. Probably not. So here's Doug Smith again, because of course I want to show you how to remove fields. And how you do that is, we'll go remove field, and we'll say Doug Smith again. And what we want to remove is Doug Smith's wife. So sorry, Patty, that was a short marriage once again. We could also check for a field. So we could say is field, if I can spell field correctly, is field, and we can go and find out if Doug Smith has a wife, and that will provide that information. We can also go and get all of our fields from the Doug Smith structure, and to do that we can just go field names, it popped right up, and then Doug Smith, exactly like that. We can also store structs in a vector, so we could do something like customers and 1 is going to be equal to, and we could just throw Doug Smith inside of there. And we could also go and let's say we wanted to do another one. Maybe we just want to copy this. So we're going to go Doug Smith and copy this, throw this down inside of here, and we'll change this to Sally Smith. So Sally Smith and name, and of course her name is Sally, so that needs to change. And let's just leave, let's say this is 18 or something, just to do something different with Sally. And then we can go customers like this, and we will add a new Sally Smith customer to our vector in the second position. And we just type in Sally Smith like that. And then of course we're going to be able to get all this information. We can just call display, and customers reference the second customer, and let's say that we want the second customer's name. We can do all that. Definitely have to get a drink. You can see over here all of the different information. It's kind of cool how it outputs all of that information. Let's run it again. So here is all information, and it says a 1x2 struct array containing fields, and then it outputs all that. So it's providing some additional information, which is also interesting about exactly what type of data we're working with. All right, and there's the gist of how we can work with structures, and now I want to talk about file I/O. Exactly. Structures are very much like dictionaries in Python. Yes, they're just called structures inside of Octave. Really, if you know Python, you really shouldn't have that much trouble learning Octave. It's a very intuitive language. It's very easy to understand. If you're wondering why I'm teaching Octave, it is because that Octave is a fantastic math, science-based library that's basically Matlab for free. And you're going to see we can do plotting and all kinds of other cool stuff here in a minute. But it also is very often used in machine learning courses, and I wanted to provide it because I went on YouTube. I'm like, oh, I'm sure there's great Octave tutorials on YouTube, and there's like none. And I was just like ugh. What is it? Most of the ones I was finding were like really old. Let me see here. How many Octave tutorials are on YouTube? None. There's not many at all. So tutorial. I mean, there's some, but not really. They're all 3 years old. Yeah, they're very old videos for the most part. It was mainly just like two guys who seriously tried to make an Octave tutorial. Like, there's like 2 people. Hey, Stan, what's up? Thank you for stopping by, Stan. Always appreciate it. Okay, so what I want to talk about now is file I/O. You can, of course, save your data, pull it back. You haven't? No, I never made an Octave Learn-in-One video. This is never. This is the very first one I made. I thought for certain that somebody had made one. Nobody's ever made an Octave Learn-in-One. Well, that's not true. I think somebody made one, but it was not. It didn't cover as much as I'm covering by a long shot. It is a rather short video. And then I think only one other guy did a multi-part Octave tutorial, and the rest of the stuff on Octave is either extremely old or it's, you know, kind of slow. All right, so let's come in here and let's generate a random 8x8 matrix that is going to have values between 10 and 50. Random I, that's what it does. Random values. We want 10 and 50. On Octave. Not sure what you mean by that. I have never made an Octave Learn-in-One video. Never. And one guy did, but he sort of, you know, he looked like he was rather new to making videos, which isn't a bad thing. There you go. I just automatically generated a random 8x8 matrix, and you can count those rows and all that stuff if you don't trust me. Okay, so let's now say that I made this. I want to save this file as a text file. All right, so to do so, it's very simple. You just type in save, and we'll call this sample data and dat, like that, and I'll go random m, like that, and then I'm going to say that I want this stored as ASCII, and we can go and we can run this, and you're not going to really see here where it is. Let's see if I can find it. Oh, is it here? Yeah, I think I saved it here. Yeah, sample data. Yeah, dat file. There it is. Oops, it wants to. What is this? I don't understand why. Oh, well, I'm just being stupid. This is not in human readable text format. That's the reason why you can't open it. You could open it, but it's just going to be garbly, you know, garbage. So what I want to do is I want to read the data into a matrix with the same name using that file. How you do it is you just type in load, and you're going to type in whatever the name is that you named your file. And then what you can do is you can just go and display it. So I'm going to go samp data like that and run it. And you're going to see that it outputs that information. So it actually read the data in from the file, and then it output that same information here on our screen. So that is how easy. And you can also save as text data. So if you want to save this as human readable data, well, you just say save again, and let's call this sample text, and it's a text file. And random m and ASCII like this, and then we can go and load sample text dot text, and then we can also display it. So sample text like that, and run it, and you can see, whoops, what is that? No such error. Oh, I typed in this wrong. So let's just type this in like that, and now run it, and you can see that we were able to get all that information out of there. And if we go into this, you can sort of see, it's kind of small, but you can see that it's stored as human readable text inside of that guy. So that's how we can read and write that. And another thing we can do is we can actually display file data just by saying type and sample data dot dat like that and run it, and we're going to be able to, well, oh, it also outputted all that information there. Okay, so that is how we can both load information from files and save information from files. As you can see, we're getting close to the end. All right. Now we get to functions. I'm losing my voice. How you create a function is you type in function. And let's say I have a function that it's going to be called vol. And what this means is vol is actually going to be the return value for our function. And then we're going to have, let's call this something like, let's type cylinder and volume. I'm just going to copy that. And it's going to receive a radius, and it's going to receive a height. And then what you need to do inside of your function is actually assign a value to the value that will be returned from our function. So what we can do, pi is also built directly into Octave. Of course, it's a math library. It pretty much has to be. So what this is going to do is get the radius passed inside of here, square it, and then multiply it times whatever the height is. And then with any function, you are going to end it with end. Now, how you can go and get this, well, another thing that's kind of neat is you can do something, you can type in tick and talk. I love this. I wish other languages did this. Okay, you can just simply type in tick and talk, and it will actually calculate how long it took to make all these calculations. Of course, it's not going to be long. Now, if you want to go and calculate or get your function or call your function, you just call it by cylinder volume, which is what we're working with. And I'll pass 20 and 30 inside of it. And we're going to get all kinds of additional information. So we can run this. Well, it output all that information. But you can see right here, we're able to go and calculate the cylindrical volume. And you can see exactly how many seconds it took to make that calculation. I'm going to get rid of all this stuff so we don't continue to open and close files in the background. All right, so kind of neat. I love the TikTok. I think everything should have TikTok. Okay, so what else do we need? If I ever write my own programming language, I'm going to implement TikTok into it. Okay, so let's try to change a variable value inside of a function. It's very important to understand how that works. So I'm going to create a function, and it's not going to return any value, and I'm just going to call it return value, because remember, if it's going to return a value, this is actually the name of the function, this is the name of the function, this is the value that's returned, and these are the two parameters that are passed inside of it. Yeah. Not going to have anything to do with the TikTok. You know what? I don't think I've ever actually looked at TikTok. I know that it's the bane of the schools around, because they constantly kids post on TikTok all these like tricks and pranks to pull at school, and teachers hate that because they were tearing destroying the bathrooms. Guess how the solution? What is the apps? Okay, so we're in the middle of a pandemic. This is a live stream, so I'm just going to talk for a second. I should probably stop talking because I'm losing my voice. Okay, so these schools, the ads on YouTube are ridiculous. What? I only ever put one ad on YouTube ever. So you're never going to see ads on YouTube from me. I put one 5-second skippable ad at the very beginning. You skip it, you never see an ad. I don't care if the video's like forever long. Okay, so basically, anyway, the schools had their bathrooms destroyed, and our local school's solution to that is to remove all the soap dispensers and all the paper towels from the bathroom. So in the middle of a pandemic, our schools had no soap and no paper towels. And it's still to this day, they have no soap or paper towels in the bathroom. I found that to be the most insane solution to a problem I've ever even imagined. Okay, so what we're going to do is we have a function, and it's called change value. It's excruciatingly dumb, and they continue to do it. Okay. So what I'm going to do inside of our function is I'm going to define a local variable. Okay, so its value is only going to be within our function. And I'm going to call it change me equal to 10. And inside of it here, I'm also going to call class on it to get some additional information on the change me function. And then it is going to end. Okay, so here's our function. Now outside of the function, I'm going to define another change me variable, and I'm going to assign it a value of 5. And it's just very important to understand how values are handled whenever you're passing them into functions, local variables and things like that. That's another reason why I'm doing this. Okay, so I'm going to call change value, and let's see if the value of change value changes by calling this function or not. Okay, so let's call change value, and then I am going to, what else do I want to do with it? Well, I can do f print f and call change me, and then like this, and still laughing about the solution is to remove paper towels and soap. I still can't believe that. Okay, let's run this and see what we get. So here we are. Patty Smith's still doing things and things like that. All right. So here we go. Here is change me. You can see it has a value of 5. That is this right here. This line is what's being executed. Then you can see that we have change me. This is actually coming from inside of our function. And you can see that we made no changes to, this is a local variable. If you change a value inside of here, even though the variable name is the same, it has no effect on the values that reside outside of the function. So I just wanted to make sure that you understand that local variables operate that way inside of Octave, because sometimes they do and sometimes they don't, depending upon different programming languages. So it's very important to understand. What happens in situations in which you have functions that don't have any different arguments inside of them? Well, you know what? Well, I'll just leave that there for now. Let's go function. That's how we define every single function. And we're going to create a random number, and it is going to be equal to, I'm just going to call it get random num, like that. And then we will say random num is equal to, and we'll call our rand I like that. And we'll do like a number between 1 and 100. And then we have to end our function like this. And you can see here, there is the value that is going to be returned. And this is the name of our function that we will be calling. And we can just call get random number like that and run it. And you can see that it was able to generate a random value. This 32 actually comes from this line. It actually, whoops. If I put a semicolon inside of here, it is not going to print. And you can see now, say it only prints this. And it's a random number. Before it was 32. So anytime you don't want something to show in the output window, just put a semicolon after it and it disappears. What do we do if we want to return more than one value? Well, very simple. We can just go and create another function, and we just inside of brackets, let's say we want to calculate the volume for cones as well as cylinders. Well, we just type in, I'm going to type in cone volume like that, and cylinder, let's just go like that, and volume. And it's equal to, and the name of our function is going to be get volumes, and it's going to be passed a radius and a height. Those are the parameters that are going to be passed inside of it. And now what I can do is I can just go and define both of these, and they will both be returned. So it works extremely well. So cone volume is 1/3 times whatever. Well, let's do our cylinder value. So we'll do we're going to actually calculate the cylinder volume. So we'll go cylinder like this is going to be equal to pi times radius squared and times our height. And then our cone value is going to just be 1/3 of our cylinder volume. Okay. And we'll just paste that in there. There's really no point. It doesn't matter if this is correct. We can just do this. Just showing you how to return multiple different values. And then how you get them is you can go cone. I thought it was going to show me that. Cone volume like this. And let's make it V just to cut down on any confusion. Cylinder volume. And we will keep that inside of brackets. And then we'll say that we want to call this function called getVolumes and pass 10 and 20 inside of it. Like that. And there we are. And we'll be able to get multiple values at the same time. I'm drinking so much water. Another thing is there's something called eval, and it allows you to execute code as a string. I'm going to call this. So we'll go to execute is equal to, and we can go sprintf. This can be useful in some situations. So we'll go sprintf. I'm going to say total is going to be equal to, and d like this plus whatever this guy is right here, and pass 5 and 4. And you can make basically anything you could want with this. And then we can just simply say eval and call this string to execute that. And run it. And you can see total is equal to 9, pops back. And you can make really elaborate calculations and have them execute. Okay. We're almost done with anonymous functions, recursive functions, and some plotting and stuff. I don't know how those people do those 4-hour streams. I mean, I would think that they would just fall apart. Okay. All right, so I covered eval. Let's say I am talking, right? Yeah, I'm just making sure that my microphone is on. Okay, so let's say we want to accept a variable number of arguments. So we have no idea how many different values are coming. Well, always start with function. Let's just create sum, and I'll call this getSum, and you're going to type in VAR ARGIN like that. And then we're going to say sum is equal to 0 like that. And what we can do is we can cycle through the contents of all the values that were passed inside and output them. So we're going to use our trusted friend, the for loop, and we're going to say, oh, this is just K. I was confused for a second. Okay, so we're going to do length of the variable. There it is, like that guy. And then we can just go and add up all the values of sum, just like this. So we'll just go like that, and we'll go and get this guy, and then throw K inside of it, and then 1 after that. Then we have to end our for loop, and then we have to end our function. So pretty neat. And now what we can do is we could do something like the sum is equal to getSum and pass as many values as we could ever want to pass inside of it. And it's going to just automatically work, which is awesome. All right, anything else we'd like to do? Let's say we want to return a variable number of values. So we have no idea how many values are going to be coming back. Well, in that situation, function again. And we're going to type in var arg out, variable number of arguments out, equal to, and I'm going to call this get numbers. And what we could do is we can just say, like, how many values do you want to get? Just silly sort of an example, but useful nonetheless if you want to know how to return a variable number of values. There's really some things in Octave that could be stolen and put in other languages that I think would be very useful. So how many values do they want? And then we could say variable argument, and we could do variable, or we could do anything we want. In this situation, I'm just going to keep it simple. I'll just do K, and then I'll go and put K inside of here, and end for our for loop, and end for our function. And now you can just say, how many functions do you want? I want you could throw a random number generator inside of there. You could throw basically anything you want. And I'm going to say get numbers, and how many do you want? And I'm going to say that I want 10. And if we run it, it's automatically going to generate. Whoops, what did I do wrong? The one thing about the Octave GUI is the errors are not particularly wonderful. Let's see what I did wrong. Function variable, I called that. I got list of numbers. Get numbers. What did I type in? Oh, a variable argument out. I forgot to type the OUT part. There it is, and run it. And there you can see we were able to generate all those values. They're running off the screen, but we generated 10 values. We could also generate random values or pretty much anything. All right, so that's pretty much everything you could want to do with functions in their basic form. How do anonymous functions work? Well, let's go and create function, and here's a solution it's going to be passed, and I'm going to call this do math. And it's going to be passed a function and a number. And inside of it, the solution is going to be whatever the function is, and that function is going to perform some type of operation on the number that was also passed in. So we're going to make sure we close off our function. And then what we could do is we could say function and just call this func is equal to do math 2 and number like this, and we can inside of this one we can say func is equal to, and then you're going to use the @ sign for a anonymous function and x, and then we're going to take x times whatever the number was that were passed inside of it. Then we can go and end that function. And basically just anonymous functions are just one-line functions. So, and the format for these is basically going to be whatever, just say name of func is equal to, and then you're going to put your @ symbol and this attribute, and then you're going to put in whatever your function body is. And semicolon. So let's go cube volume, and I'm going to follow that exact same format. So I'm going to go equal to, and I'm going to say @ and then these are going to be all the different attributes that are going to be passed inside of it. And then after you do that, you can throw in what mathematical operation you want to perform. So let's say L times W times height. There you go, all on one line. And then we could say CV is equal to cube, whoops, volume, and we can pass in 2 and 2 and 2, right like that. And then we can pass a function into a function. So we'll say multiply by 3 equal to, and the @ symbol, again, some value passed inside, and then some mathematical operation afterwards. And then we can get our solution is going to be equal to, and we can go do math and pass in multiply by 3, and 4 is what we want to multiply times. And let's go and run it. You can see what exactly this looks like. Oops, solution file. What'd I do? Forget to put an equal sign or something? Solution function. Let me see. Yeah, I forgot to put an equal sign. There's my equals. There we are. And run it. And you can see, whoops, k undefined. What did I do? I think I got that right. Starting to get overwhelmed a bit with my throat hurting. Function equals to math 2. Get a pass that inside of there. Not quite so sure what exactly I did wrong. Is equal to name of function. That symbol. Not sure what the problem is here with this. Is this causing an error? I don't think so. I don't think that's it. Let's run it. I really wish error K undefined line. Yeah, the GUI for this is kind of crappy. 147. This is passed inside of here. Oh, okay. In this situation, it actually is telling me some of the information that's incorrect here. So it's on line 147, and I have my cube volume is equal to at LWH, the attributes passed inside, L times W times, that's what's wrong with it. This is H. Sorry about that. And run it, and now it should be right. Yes, it is. And you can see those solutions. So that's how we can use anonymous functions. Let's stretch here for a second. Okay, what else could we do? Well, we could also return a function. So we got all these different guys inside of here. Let's go mult and 4 equal to, and I can call do math 2 and 4 like that. And then solution 2 is going to be equal to mult 4 and pass a 5 inside of it. And we could run that as well. Okay, so there we go. Multiple different things. All right, so now what I'm going to do is I'm going to show you how to use recursive functions in calculating a factorial. So we're going to create a function. So again, we have to type in function, and value is going to be the name of the variable that's going to be returned. So whatever that is, I'm going to call my function factorial. It's going to be passed a number inside of it. And basically, if you know anything about programming, you know that a recursive function just has to reach a point at some point in which it stops calling itself. And a recursive function is a function that calls itself over and over again. I assume if you're watching this video, you probably know that. If you don't understand, just ask me a question. I'm here live. I'm talking literally right now. So if you don't know exactly what a recursive function is, that's not a problem. I will explain it further. I'm kind of guessing most people here know what a recursive function is. If not, that's cool. Guess what? At one point, I didn't know what a recursive function was. You wouldn't believe that. Okay. So what we're going to do is we're just going to calculate the value. And of course, this is going to be number times and factorial. This is when I am calling the function itself. See, factorial, and I'm calling the function itself with factorial. Now here, number, whatever number they passed inside of it, is going to decrease in value. So decrease, 1, exactly like that. And we're going to continue doing this over and over again until we can't do it anymore. So we'll do this. That's going to end our if-else loop, or if-else conditional statement. And there we go. And now what I can do is just come down inside of here, and I can go and call it. So let's say we wanted to get the factorial 4. Well, that's going to be equal to, and I'll factorial of 4, and just pass that inside of it, run it like this, and run it. And we are able to calculate factorial. It comes back as 24. How does this work? Well, we pass a 4 in. That's this 4 right here. We then call the factorial function again with a value that's 1 less. How does that happen? Right here. And then we jump down here. Here's calling the factorial function the second time, now with the value of 3. So this right here is actually this right here. And then this right here is actually this right here. But then we have a situation when we call the factorial function here where it gives us a value of 1. If number is equal to 1, we will return a value of 1. That's what this 1 right here is. Well, now we know 2, and we also know 1. We know this is 2. That jumps up here, and so forth and so on. And it basically goes down the list, and it comes back up. And finally, the 6 goes here, and then we multiply that times the original 4, and that's how we get our final answer of 24. Okay? And that's the gist. Let's cover plotting here really quickly. There is gazillions of ways of plotting data using octaves. I'm going to give you just a overview here of the basics of plotting. So, let's say I'm just going to do it real simple. Thank you very much, Killer Knight, for following. Okay, so let's define, I'm just going to do a simple line plot. So I'm going to go x values is going to be equal to 1 through 5, and the y values, and this is going to be equal to 2, 4, 8, 5, and 9, like that. And I'll have my y values again, and this is going to be another set of y values, so I'm going to call this y values 2. You can plot multiple different plots all at the same time. I'll make this 1, 5, 7, 6, and 8, like that. And whenever you want to create a plot, you have to first create a window. It's literally going to create a new window that's going to pop up on screen. And I'm going to call this figure. This is figure 1. I typed figures, figure 1. Okay, so that's what that does. And then you can define tons of different things. Here are the different ways of defining your plot colors. So if you want blue, you just type in B, black K. Oh, there's a whole bunch of line colors. Here's a whole bunch of different plot symbols you can use. I'm going to demonstrate this in a second. There's numerous different line types. You can have just simple dashes. You can have these colons and such, and all of this other different stuff. So what I'm going to do, remember, this is the window we're going to be plotting into, and I'm going to show you how to create a line plot. So you just simply say plot, like that, x values, like that, y values, and then you can play around with all the different symbols. So I want this to be green, and I want it to have a plus symbol, and then I can define my line width. So these are going to be representative of all the individual points in the line, and then I have to define exactly what I want my line width to be. So I'm going to type in line and width, like that, and let's say I want my line width to be equal to 2. Okay, so there's one plot. Let's say I want to create a second plot in the same window. How do I do that? It's really funny. I type in hold on, whoops, hold on, like that, and then I just put in another plot. So I think that's like so funny. Octave has some really funny things, and I think this actually is the same way that Matlab works also. I'm a little bit vague on Matlab. I haven't used it much lately. Because why? Octave is free. Okay, so we can just come in here, and let's just simplify this. Let's get rid of this. And I'm going to make this black with stars. So I'm going to say black with stars. So those are going to be the different line plots that we have inside of there. And then we can also define the look of each of the different plots. So let's say that I want to do something like the legend. And I'm going to say y values and, whoops, well, I'm going to do this and just put my little quote inside of here. So quote like that and quote like that. And y values 2. Oops, and I need to put those inside of quotes. And like that, and like that. And let's run it. Oops, syntax error. What did I do? Line 70. What? Line 79. Oh, I forgot to put an equal sign inside there. There we are. Run it again. And you could see that it actually created the plots right here inside, and you can of course zoom in, and the legend needs increased in size, but it still works. Okay, so you get the gist of the basics of that. And then what we can do is, let's say we wanted to go show a grid. We just simply say grid on, and now we have a grid. And let's say that we wanted to define X and Y labels. Go X label and put days inside of that. It's like that. And for the Y label, whoops, it's lowercase label like this. We could have it be something like, just write money. I don't know. We could go and give it a title just by saying title is equal to money made today or something like that. And we could also do bar charts, something like that. So we can do it at the same time. So this just creates a new window like that. And then we could do bar like that, and X vowels like that, and Y vowels, and let's say we want them to be red or something. I don't know. This is actually going to open up two windows at the same time. So there's our bar chart that we have, and you can also label them in exactly the same way. And here is our line chart with our titles and all those other different things. So now I'm going to leave it to you guys. This is the end of Learn Octave in one video. I'm going to ask you a question. Yeah. So do you want me to show you how to solve the very first problem using Octave in multiple different ways, which is the cost function, from the Andrew Ng machine learning course? Tell me. If you want to see it, I will try to make my voice survive long enough to teach it. Do you want me to see it? Do you want to see it, or do you think you've learned enough? I can do it right now if you want me to. Probably have to go get another glass of water. If you think that's enough for today, I will stop. If you don't, I will continue. If it's quick, it'll probably take at least 15 minutes. Let's see. I have to actually use my iPad to do this, because I'm going to actually solve the problem using, yes. Okay, you want me to do it? I'll do it. All right. So this is how to solve the very first problem from the Andrew Ng programming course. And I'm actually going to show you how to solve it in 3 different ways. I'm going to show you how to solve it using my iPad. I'm going to show you actually how to solve the problem on paper, like literally. And then I'm going to show you how to use for loops. And then I'm going to show you how to use matrix calculations to solve all of it. I just have to reorient my desk so that I can show you all of these different things at the same time, because it's kind of insane. Exploring new ideas here is what I'm doing. All right, so I have to connect my iPad. And let's see. There's that. And let's see if I can find what I'm looking for. And then let's see if you can actually see it. All right, you cannot see it. All right, let's do this, and let's bring this back, and this is completely crazy what I'm doing right now. All right, so just bear with me. If you want to see this, I have to do some different orientation, so you can actually see the whole process of me loading everything together and making it work. I use something called Air Server, and I'm going to mirror my iPad screen onto the screen. So how do you increase the font size and the text in the chart? I could cover that at some other point. I'm sort of wearing out here. All right, so here we are. So that is, you can hear me, right? Yeah, okay. So what am I going to do? I'm going to actually show you this in multiple different ways. This is the cost function. And this is basically a concept that we call, this is creating a regression line. All right, so what this is, well, let me show you Andrew Ning's course here for a second. I think it's in Microsoft Edge. Look at that, cutting edge. Let's go back. Okay, so what he's talking about here, this is in the probably the most viewed machine learning course in history. What he has you doing is actually calculating a regression, and the very first thing he wants you to do, there's all these formulas. I'm going to work them out by hand so you'll completely understand them. Okay, so what we're doing here is we are trying to calculate what is called a cost function, which is basically like an error function. And I think this is it, computing cost for data that he provides, and this is the answer you're expected to provide with your code. Okay, so I'm going to show you how to do this in every way possible. All right, and I'm going to explain exactly what the cost function is on paper and everything else. So let me go back. Let's get rid of this. And let's jump back to this. All right, so how do we calculate this? All right, so a linear regression is just drawing a straight line to fit certain data. So let me get a different color here. Let's say what color do I want to draw with? Let's say that I want to draw with green. How about green? Okay, so let me orient this in a way that you can actually see it. Okay, so here it is. So we have all these data points in orange, and we have another data point that we're really interested in, and it is in white. Now, with a linear regression, what we're trying to do, linear, what does linear mean? Linear means a straight line. Anytime you hear the term linear, they're talking about a straight line. So what we want is to generate a function that creates a straight line that best approximates the data that is provided to us. And that's about as straight as I can make a line. And so let's bring this down here. All right, so let me reorient this. So let's say that we have all these points are our data set. And what Andrew Ning's looking at in his machine learning course is the area of a home by the value of the property when it was sold. And he's trying to create a formula here that is going to figure out if somebody says, okay, I have this big of a house, he can make predictions on exactly how much the house is ultimately worth. Now, let's say we have a line that we start off as a prediction. Everything starts off as a guess, and this is clearly wrong. So here is our starting point with our guess on home values in green. Now, whenever we're trying to figure out where this line should be adjusted or how we should change the slope on it, well, let's say we have this point up here, the white dot. What we're going to do is we're going to, I'm trying to figure out what color to use in this circumstance. Maybe we'll just use white. All right, so here is this line right here. And then we're going to have another point that is going to go over here. So this is what our false first guess is for the value of that house. So I'm referring to this white dot up here. This is an actual value, and this is our predicted value. Now, in this circumstance, we would know that there would be an error or a cost difference between those two values. And so this is our error. I'm going to write error right here. So here is error, right like that. So that is how much we are off based off of our line prediction. And what we want to do is slowly get this green line and move it up so that it approximates all the values of homes if we are looking at both the price as well as the area of the home. And that brings us to our cost function. And what it does is it represents the difference between an actual value, this red dot or this white dot right here that progressively is getting bigger, and this, let me see what color I should make this. This yellow dot, which was our approximation for the value. Okay, that's what the cost function is. The error. How much difference our guess is versus the actual guess. All right. Whoop, I almost dropped my pencil. So, what are we going to do here? I'm going to move this over here. And what I want to do is I'm going to show you how to calculate this. Now, this is the cost function. It looks really complicated. J is equal to 1, 2, m. You can see this, right? Yes. And then this represents the sum. After I write all of it out, I'm going to explain what every single symbol means. So this is going to be I, 2, 1. And then we are going to have theta 0 minus theta 1. And this is going to be squared. All right. So we are going to be using this multiplication. M is equal to the number of data points. So the number of data points, that's what it is that we're analyzing. Okay? So the total number of data points that we have here, all these orange guys that are bouncing around. This right here is just going to give us the average for those data points. This is the, let's switch to, let's use white, that's fine. This is going to cycle through every single data point. This is a sum function, so it's going to go from the first to the last. So that's all that's doing. And then what's it going to do? Well, this is the actual value. So this is the actual home value based off of area. And this is our guess or our prediction. Okay? And then we square everything. The reason why we square it is to make sure that we ultimately get a positive value. And then this guy over here is going to make sure everything works out. All right? So let's make this extremely simple to understand. Let's say that we only have one data point, or we only have 3 data points. So let me see here. What can I do? Let's bounce over here. That's not it. Okay. So I'm going to copy this. Can I do that? No, probably not. Let's copy this right here. And copy. All right. And we will, maybe we'll get rid of this altogether. So let's just, it disappeared. So we're going to get rid of this and we're going to replace it with a fresh graph. And I'm going to use a very simple example. And then I'm going to actually show you how to solve it using regular by hand mathematics. I'm going to show you how to solve a cost function with pure math. All right, so here we are, and we have, in our circumstance, we are going to have 3 data points instead of that mammoth group of data points. Doesn't matter. And our data points are going to be at 1, 1, so right here. I think you can see that. Yes, you can. We're going to have another one that's going to be at 2, 2, so that's going to be right here. And another one that is going to be at 3, 3. Okay, so here is our data points, and they perfectly line up. Data never perfectly lines up, but a regression line is always going to be able to estimate. A regression is just an estimation of the line. So what we need to do is we need to create a guess for what this line is. It doesn't matter if our guess is anywhere near being accurate. It just needs to be a guess. So let's say that our guess is actually that we have our point here at 5, 5, and well, let's not do that. Let's keep it 1. So it's going to be here. Yeah, let's do that. So let's have it be 5, 5 like that. And let's have it be 1, 1, And let's have it be 1.5. So what this is going to do, let's go and bring us back. I'm trying to make it very, very simple to understand. So at the 1 point, it's going to be 1/2. So we're pretty close there. And however, at the 2 part, it's going to be at 1, and at the 3, it is going to be 1.5. So it's like this. Okay, so here is our guess. This is our guess line that we have made. Now, how can we take this data point that is here, the actual lines that we're working with, and our guess, and figure out the cost function for it just purely using regular old mathematics? We're going to use our cost function we see here, and we're going to say that we are going to be increasing in value for each point by 0.5, and this is going to be equal to 1 divided by 2m, this exact same function. What we're going to do then is we're going to take our actual value, which is 1. We're going to subtract from it our guess, which is 0.5. We're going to square that. We're then going to add. We're going to put the actual value, 2, minus 1. And if at any point this doesn't make sense, just tell me and I will explain it. All we're doing is we're subtracting this value, which was our guess, from this value, which is an actual, and we are squaring it. That's all we're doing. It's pretty simple. Plus actual value minus our guess value, like this, squared. If we do that, this is going to end up being equal to 1. This ends up being 1/6, like that, because 2 times 3. And then this is going to end up being equal to 0.5 squared plus 1 squared plus 1.5 squared, which is going to be equal to 1/6 times 0.25 plus 1 plus 2.25. And this also ultimately gives us an answer, which is going to be equal to 3.5/6, which is going to be equal to 0.583. And that is our cost function. That is what it is. And as you're guessing these lines, like let's say that instead of 0.5 over here, you instead had 0.75. That's going to give you a lower cost function. Now let's say that instead this was 2. That's going to give you a bigger cost function. So the whole idea is to try to figure out how to make your yellow line right here get closer to the orange line up here just by adjusting the slope. And that is really the basis of basic machine learning, is regression analysis, and that's what this is. And I need to get a drink. All right. Now I'm going to show you how to do this in code in multiple ways. So I have to move my iPad out of the way. Let's get this out of here, and we'll jump in and look at it as code. Here's some more stuff in regards to other plotting options that are available to you. I will name this cost function, and I'll put it in the non-existent Octave folder, that project folder on GitHub. Inside the comments, I posted my location for all my code. Okay. So 32, remember? Anybody remember what our goal is for the cost function? Well, this code is actually taken from the Andrew Ning file. And all it is it's just loading some data into for us to do analysis on. Okay, here is all of said data that we are loading. Here's our cost function. So what we're going to do is we are going to, please refrain from spamming symbols. Huh? I don't know what's going on. I don't know what's going on. Okay, so here we go. We are going to, this is all kinds of additional information on how to mess around with different plottings and so forth. This is basically what the Andrew Ning file has inside of it is the population in cities and the profits for said cities. And it just loads all this data in, and I have to create it using a for loop, a cost function, and then I'm going to show you how to use matrices to also do it. A lot of stuff. Okay, so what can we do here? There is our label. I gave this message. Sorry about that. I have no idea what I have no idea what Streamlabs is doing. It's just randomly it does strange things. I apologize. So what we need to do here is I need to add a, well, let's just go. I'm trying to think of how to best explain this, because I'm going to use something called theta. And what theta is going to do is it's actually going to take those dots that we had and it's going to move them up by a certain percentage to weighting. But we're only using two things, which is basically the population of the city versus the profit value of our home. So it's only two pieces of data. I don't know what it doesn't like whatever you're typing, Tech Trader. Apologize for that, but whatever. So what I want to do is I want to calculate our cost function, which I just showed you how to do on, and I'm going to show you exactly the same exact example. So I'm going to define x is going to be equal to, x is going to be our guess values, and this is always going to be true. X is always going to be representative of our x values. And what I said was it's going to start at 0.5. It's going to increment by 0.5 every single time up to the value of 1.5. Okay? So that is, these are our guesses for the values. Y always will be referred to as the actual values. Here, we're going to start at 1. We're going to increment by 1 every single time up to a value of 3. Okay? So that's exactly what I just showed you in that chart that I was drawing in the simplified thing. And our goal is to get an answer of 0.5833, just like we did before. We also are going to have our x. If I try to type within 30 seconds of my last try, yeah, 32. Okay. Yeah, I don't know. Streamlabs is weird. I apologize. It's just some weird thing that I can't control. Okay, so we also need our x-axis values, and they're going to be 1 through 3. And that is how we define that using Octave. And now what we need to do is create a function, a cost function. So what do? We type in function, and it's going to return a j value, just like I used whenever I had it before. I'm going to call this cost func. It's going to receive x. What's x? X is our guess for the data. It's also going to receive the actual data, and then it's going to tell you the difference between your guesses and the actual data. I'm going to create total, which is going to store my accumulated errors, and I'm going to give it a value of 0. I'm going to m, remember m that I drew out? Well, that's just the number of pieces of data we're working with. And I'm just going to use y. I could use x. Doesn't matter which one I use. And then I just need to cycle through those values while calculating the accumulated error, just like I did on paper. So I'm going to say for I is equal to 1 through m, the number of values we have. I'm actually going to print this out. So I'm going to say f print f, and I'm going to say x and I is going to be each accumulated value that we have. And I'll go and print this out on the screen just so you can see it. So this is going to be a float. I'm going to throw a new line inside of it. I forgot to put quotes around this, so let's put quotes here. So quote like that and like this. And basically, I am just showing you how to solve that problem using Octave instead of Python and all that other stuff. If you know Python, you should be able to do this quite easily. So we got all of that. I'm going to copy this, paste this down here. I'm going to output our true value onto the screen, and I just need to change this to true value. I don't need to do this to make this calculation. I'm just doing it just so it's easier to figure it out. Then we're going to have our squared error, just like I calculated previously. And our squared error is going to be the value, the actual value we want to try to model. So each of those minus the guess value that we have inside of here. And what are we going to do? Well, it's called the square error for a reason. It's because we square it. And why do we square it? We square it because we want only positive values. Because we care about the total difference in regards to the error. We don't care if it's above or below. We want the total. Okay, so we calculated that. Well, total is going to, you know what? I'm going to do this. I think this actually does work. So square error. We'll find out. If it gives me an error, we're not allowed to do that. Okay, so there we are, and we're just accumulating that, and let's go and also print that total out each time we cycle through here. So we'll pick this like this, and I'm just going to say total like this, and this is just so we can see the value changes over time. Okay, I'm not going to be able to talk for a month after this. Okay, so that is the end of our for loop. And see, Octave doesn't care where I put the white space. I just do it that way. Then after we go and we finish with our for loop, well, I'm going to put it over because it's bothering me. Okay. We are going to return our accumulated errors divided by 2 times the total number of values. So J is equal to the total. I'm looking over my microphone trying to see the screen. Times, and it's going to be 1 divided by 2 times the total number of values, and that is going to return that. So then we can say end, exactly like that. Okay, so now there is our cost function, and what I want to do is I want to create a plot. Here is our plot, and I'm going to go plot, and I'm going to do x, y, and what do I want to do in regards? Let's just do g. Let's use plus signs, so it's going to be green. This is going to represent our actual data. And then I'm going to have line and width like that. And let's make that be equal to 2. And what do we do if we want to have multiple plots? You type hold on like that. I still love that. Oops, it won't get rid of that though. And then I'm going to plot my guess. So this is going to plot our actual values. This is going to plot our non-actual value, our guess. So there's x, and I'm going to make this black instead, and everything else is perfectly fine in regards to that. And then what I can do is also call our cost function. And remember, it's supposed to give us a value of 0.58. I'm not using the Andrew Ning data yet, which is going to be 32.07. I'm going to pass in my guess. I'm going to pass in the actual, and I am going to, that's it. That's all I'm going to do. Pass in both of those pieces of data, and figure out what happens with that. So let's run that, and you can see it plotted out the actual as well as my guess values right there. And what is it doing? Let's come over here, CLC, clear that, and I'm doing that just so I can see over my microphone. Why undefined near line 40? What did I do? I apologize, but I've been talking for 3.5 hours and my voice is totally dying. Okay, so what did I do wrong here? I have that. Cost function is equal to this. Oh, I think I have to put a 1 inside of here. Whoops. Yeah, there we go. So you can see right here my cost function, just as you would guess it does, what it's going through, comparing those multiple different values, getting the 0.25, it's subtracting these values, the actual from our guesses, and ultimately what it's able to do is calculate the cost function. There it is. So that is how you would implement that using a basic for loop. Now, the really awesome thing is you're actually able to do exactly the same thing using matrices. And that's the reason why linear algebra is so ridiculously complicated or ridiculously important whenever working in machine learning, because it'll take this really long thing and convert it into a couple lines. It's so awesome. So what we want to do here is we want to calculate the error using linear algebra, and then on top of that we are going to use different theta values, and what we do is we are going to try to weight our guesses versus the actual. And by weight them, I just mean we're going to multiply a value times each of our guess values to move our line up. And that's literally all that we do. I'll show you how to do this. Let me see here. I'm going to show you how to do it on the iPad. So just give me 1 second. I'll just grab my iPad. So with linear, I know you don't know, well, some of you probably don't know linear algebra, but I'm going to show it to you anyway, because I think you'll get what exactly is going on here. So if I can turn my iPad on. Okay, so there it is. Okay, so let's jump back over to this. So here is this, and what I'm going to do is I'm going to show you how to incorporate weightings, and by weightings I just mean that, okay, so here is our guess, and the actual is the orange dot above it. This is the guess, orange dot above it, that. How much do I need to multiply these guesses, that's the weighting, to make our yellow line move perfectly in line with our orange line? That's what we're going to be working with right now. So, how about, can I just get a new one? Yes, I can. Okay, so this is how we do cost functions using linear algebra. So this is a matrix version of our cost function and how we can work with it. So in this circumstance, x, these are our guesses, remember? So we're going to have, I'm keeping this simple, but this formula will work with the more complicated one. I'm just using this as an example because I think it's very easy to understand. So these are our guesses. Then we're going to have our actuals. So here are our actuals. That's 1, 2, and 3, like that. And then we're just going to, theta is going to just mean weighting. Like how much are we going to change these values right here to make them these values right here. That's it. But I'm going to actually put 0 inside of here. We're not going to change anything. So what are we going to do? Well, we're going to take our x, our guesses, minus our y's, and that is going to end up giving us a new, this is going to be a column vector with the value negative 0.5 and negative 1 and negative 1.5, like that. And then if we take, what we're supposed to do is go x minus y transpose, and this is going to give us, all we're doing is moving the, we're changing from a column vector into a row vector. So this is going to be negative 1 and negative 1.5, exactly like that. Well, what we have to do at this point, oh, I'm not showing you. Oh, sorry about that. It's not showing it. Ah, silly, stupid thing. There we are. All right. Sorry about that. I don't know why I didn't notice that. Oh, let's just move it down here. Okay. It's not the neatest thing on earth, but this is the very first time I've ever tried doing this, so I apologize. Okay, so what we do now, we have all of these different matrices, and this is how we are going to go and make the calculations to get exactly the same answer, but we're doing it on paper or an iPad in this circumstance. So what we do is we take our guesses minus y, actual values, transpose, multiply that times our guesses minus y, not transpose. And what this is going to do is give us our values, which are going to end up being 0.25 divided by 6, and 1 divided by 6, and 2.25 divided by 6. Remember, the 6 comes from the number of values. Remember we did this? This is where the 6 is coming from. This 6, same 6. But we're using matrices to basically do all of this stuff, where the summing of all of those values. Instead, we can use matrix linear algebra to make the same exact calculations. Okay, and this ultimately ends up being equal to 0.41, 0.166, 0.375. And if you add all those up, that ends up being equal to 0.58. I'm not going to get that much into theta and all of that stuff, but I will show you how to do these calculations in over inside of Octave. So let's just go back there. Okay, so we are back. I have to move the iPad out of the way, and then I'll show you how to actually write the code. Which iPad app, or I'm using GoodNotes, is what you're watching me draw on. Okay, so let's just go and convert this. I know it's a little bit complicated, but basically, especially if you don't know linear algebra, because so much of machine learning is linear algebra. I'm going to make a learn linear algebra in one video, probably in 2 weeks. And it's not hard. It's just you have to start at the most basic and move up. Okay, so I showed you how to create a cost function using a for loop. Now I'm going to show you how to do it using linear algebra. Pretty simple. It's somewhat complicated. And you can see here are the calculations that I made using all those different data points and how everything works out. Again, I'll upload all this to GitHub as soon as I can, in a couple hours. Okay, so now what we need to do is just model this inside of Octave, and it's not really that complicated. Wait till you see. Okay, so you see how many lines of code we have up here for our cost function? Well, let me show you how hard it is whenever we actually use matrices, and this is the reason why matrices are used. So function, we're going to return j, which is our cost function. We're going to go cost. I'm going to call this matrix func just to make it different than what we had before. It's going to receive all our guesses. It's going to receive our y, and it's going to receive thetas, but it's just going to be a row vector that just has a bunch of zeros in it. We're going to say we don't want to change anything. M is going to be the length of whatever y is, like that. And then this is, instead of for loops and multiple different statements and multiple different calculations, with linear algebra, what we can do is convert that into one line. J is equal to 1 divided by, and 2 times m, like that, times theta, like that. Or no, it's not going to be theta in that second. Yeah, we got to make this different. This is going to be x, which is going to be our guesses, times theta. Theta, again, represents the weighting we want to apply to our guesses to get closer to the actual values. So, so that's going to be theta minus y, like that. And we are going to get the transpose of that. I talked about transposes a bunch of times. So we're going to say times and x, x, our guesses again, times theta, like that, minus y. And the way matrix multiplication works, that is going to sum up everything. And this is the reason why we use linear algebra in machine learning so much because that's all it takes. This. One line of code. So instead of multiple lines of code, making multiple calculations with for loops and changing all that stuff, now it is one line of code. That is how simple it is. And pretty cool. So, we have our calculations that we have up inside of here. Our guesses is X and our actuals are Y. So what we want to do is we come down here. Now, before we can work with these matrices, we have to actually get a transpose of them. So we're going to say X is equal to X transpose. And that's just so they line up. Remember I said if you're doing multiplication, that your the first matrix you're multiplying times, its columns have to be equal to the rows. I'm going back probably an hour and a half into this video. But basically, I'm just going to solve this. So Y transpose, you have to have everything in the right order. We're going to have to add a column of ones to our X, just so our matrices columns are equal to the rows. I don't know. I'm trying to figure out a quick way to explain that. I explained it earlier in the video and can't really do it again. How you add a column of ones to a matrix is you use this ones function like that, and you say that I want 3 rows of ones, and that's going to add it to a matrix, and the matrix you want to add it to is our X matrix, which is our guess matrix. And then you can just go cost and matrix function like that, pass in X, and also pass in Y, and also pass in theta. Now remember, we're using theta this time, so it's going to give us different results than that 0.58 that we had before. Well, there's our plot or whatever. It's going to give us 2.33. It's because we're adding a weighting. That's the reason why it's different. But the awesome thing is, remember forever ago in the Andrew Ning course, it says that the value should be equal to 32.07. I think that's what it is. Well, we can do that. So I'm going to do that. This is the original data in the course that was based off of his question. And I'm going to show you that this function right here, cost function, is all you need to do to solve that problem. I don't know if it's 100% understandable, but to do it, what you need to do is go and get the original data from his file. So I'm going to go like this, and 1 like that. I'm going to go in, or that's the predicted value. I'm going to then go and get the actual data. So again, it's stored in this. It's in the second column of this guy. So we'll go 2 and like that. We are going to have to add a column of ones to our guess values. So I'm going to do that. Whoops. Uh-oh. What did I do? And I don't think I messed up anything. Hopefully I didn't. X is equal to, and what did we do? We're going to do this exact same thing again. So we're going to go copy, and this is going to be equal to ones. This is going to be equal to M, the number of data points, comma, and here we're just going to put in data and colon and 1, exactly like that and like that. Throw that right there. And then we are going to have our theta values be equal to, remember this is our weighting. We are saying we don't want any weighting at all. So we're just going to get a group of zeros. And then we're going to just use that data that he passed to us for analysis to generate a cost function, which is going to ultimately calculate to 32.07. And that is going to be had by passing in our guess values, our values of actuality, and our theta, which is going to be 0. And if we do all of that and run it, hopefully I don't have any errors. Okay, and as you can see, we are able, well, I guess you can't see, once we run our calculations with our new function on the original data provided with the Andrew Ning course that we get the expected value of 32.073. All right, so thank you very much for everyone who joined me for this long period of time. A lot of stuff covered all in one video. Next week, I will teach Algebra 1 and 2 in one video. So like always, please leave your questions and comments down below. Otherwise, till next time.